So this will be the first part we take a look at. Again, mostly milling. We're going to use a little bit of turning. With this one, we really don't have to do much turning, but we could do some turning to at least turn down the basics of the geometry. This one, we kind of don't need it. On the second one, and I already have this one toolpath, but we'll look at it together. This one will have a little bit more turning on it. So this will actually turn to size. We'll add a groove in. And just kind of go through some wrapping. This has some indexing on it. Just overall, just a lot of good information to know about. Now, this is a beginner kind of class. It's not going to be going too crazy. I'm not going to do any part swaps. I'm not doing any sub-spindle swaps because that all takes. I gotta figure all that out. There's a lot of not math that goes into it, but you got to have all your settings right for that to work and to simulate. So I'm really just focusing on kind of one-sided ops, front face, back. And yeah, we'll go through it. So let's get started with this one right here. Now, before I get started, let me go ahead and say save on this file. And actually, let me do something. If anyone wants a copy of this file, let me know you could just say, yes, I want it in the comments. It's the easiest if you guys just tell me, because then I can copy your email address directly from the meeting here. So let me do this. I'll send you guys, let me just pack these two parts up, and whoever wants them, I'll just send them over so you got copies of them. I'm just using the generic BobCAD machines. So that's all we really got to worry about. So let me just grab these two files. Where did I put them? Right there. And let me zip up this folder that I made. All right, so we'll do mill term part files. It's just those ones. So we'll say send to compressed zipped folder. And this will be mill term part files for webinar. Whoops, caps lock's on. For webinar. And then today's date is 12/21/2021. All right, so Don, I got you. All right, give me 2 seconds and get this email going. Let's go. All right. And then anyone else who might want this, I could just forward this on. So it should be small enough. All right. So just one of you so far has sent something. Whatever email you logged in with, that is the one that it's going to go to. So whatever email you signed up for this whole thing, that's what I'm going to email it to, because when I copy it, it comes right to me. So right here. Give me a second. Let me get everyone in here. I got a couple coming in now. Please send the files. Here you go, Ulrich. Copy that right there. And then Roman. Let me see if I could copy that one that you sent me. Give me a second. Yep, looks like it. Cool. All right. So for now, I'll send it to you guys. If anyone else. Oh, sorry, Eric. Almost missed you. Let me copy yours. All right, so I'm going to send this out. If anyone else wants the file, let me know, and I could just forward the email on in a few, whenever. Just give me a message. Let me know that you want it. I don't think I've used these in any of these classes before, so these should be new. I don't think anyone's got copies of these. So we'll get started here in just 1 second. All right, so I got everyone sent out, just sent to you, Kenneth. So yeah, it should be sent now. So you guys should be getting those emails here in a second. Again, if anyone wants it, send me a little message here and I'll send it over to you. Again, my name's Mike. I'll be taking care of you guys today. If you have any questions, put them in the questions box as they come up. No need to hold on to them. If I can't answer it right that second, I will wait and answer it eventually. So yeah, let's get started. So first things first with mill turn. I mean, we got to make stock. That's all. It's all the normal rules. You can follow the same. If you guys have seen it before, it's this little cheat sheet we have inside the help system. So I'm just going to open that up real quick for anyone who's new and hasn't seen it before. You go here to File. You're going to go down here to Help. And then when it loads up, the help system always loads the same page. So the big thing is whether or not you have this button checked, if you say use online help, we're going to go retrieve the newest help system that's loaded online. If you do not want that or you're not connected online, it will take a little bit longer to actually load the file. It won't load if you're not connected to the internet. So if you're not connected to the internet on your computer, which all of you guys should be if you're watching this, but if your BobCAD computer is not on the internet, uncheck that use online help button. Either way, though, when you launch the help system by clicking the BobCAD-CAM help, it'll always launch to the same page, regardless of if you're doing it here in with the online version or the offline version. All right. And when it loads, it always loads to this introduction page. Now, on this introduction page, we want to go to the button down here that says using CAM. And the big thing about this is, remember, any of these blue links that you see in any of the help system, when you click on them, it'll link you to somewhere else in the help system. So for this one, if I say using CAM, it's going to load up right here with the Read Me First CAM Quick Guide. Now, again, when you open this, you'll then see what we call the general process, or it's a very generic set of steps to use when toolpathing a part. Now, this is very general in the fact that you could use this for mill, you could use this for lathe, wire, mill turn, any of the versions of software we have. All these steps have to be followed, or let's say, I'll say most of these steps have to be followed. So step number one is we have to start a new CAM job. That's us telling the system what type of job we're going to be running. A lot of you guys that have mill turn might also have mills and lathes somewhere in the shop. So this is just where we're defining what kind of machine we're running this on. If all you have on your license is milling or turning, well, you're not really going to get much out of today. But if that's all you had, you'd be able to kind of choose which one. If all you have is milling, it's the only option that'll be available to you when you define your new job. And what's nice about this little cheat sheet, especially for all of those of you that are just getting started with the system, one of the most difficult things I'd say is just following the little basic steps. Where do you go to start a new job? How do you complete your stock wizard and your machine setup? So all these blue links that you see are something you can click on. And right here, it'll tell me in the top, these are the 3 different methods to start a new job. I can go to the CAM tree, go to CAM defaults, go to new job. On the CAM ribbon, there's a new job button. And on the CAM tab up at the top of the screen, there is a new job button. So there's 3 different ways to get into it. It's whichever way you want to do it. All right. So for now, I'm just going to leave this on this page here. So step number 1 is going to be let's do our new CAM job. Step number 2 is select the workpiece and run the stock wizard and machine setup. Workpieces always have to be solid models. So if all you have is wireframe for maybe a turning job, you don't have a workpiece to use. And then step number 3 is select your stock material. This is specifically for if you're going to have BobCAD calculate feeds and speeds. If you're going to have BobCAD calculate feeds and speeds, there's more that needs to be done as well. Not only do you pick the material, aluminum, carbon, steel, whatever your material is, you also have to make sure all your tools are the right material. A lot of guys get thrown off and wonder why the feeds and speeds a lot of times are so low because they're using high-speed steel tools in BobCAD, or at least that's what we're calculating the feeds and speeds off of. So as you're creating your tools and as you're making everything, you do want to make sure that if you're using BobCAD's feeds and speeds, you're calculating off the right material for the tools. Now, one huge step that I add in when I'm doing this whole general process that's specifically for mill turn is the tool crib. And I'll usually put that between step 3 and step 4 because I want my tool crib done before I start any of my tool pathing. My tool pathing is going to happen here at step 4. So that added step is one of the biggest things to do first for me. I find that when I have my when I have my tool crib set up properly, my day goes on quite a bit easier. Now with these parts, I don't know exactly what size tools to use. I got to take a couple measurements to find out what drills I want to use because I do need to make sure they're mounted. Now you could, as you work through your tool paths, you could create tools and then go and mount them, which isn't a bad idea. And I'll probably end up doing that for a few tools. But I do recommend at least getting the majority of the tools, the tools you plan on using the most, try and get those ones into the tool crib first. All right, so step number 1 in here is to define our new job. Now, again, there's 3 ways to do that. We got this little button here at the top of the CAM tree, right at the quick access there. And then if you click on CAM up at the top, you also have a new job. Or you can right-click on CAM defaults and say new job. Now, after you have that selected, you're going to choose mill turn. And then if you've had a machine built by us and you've installed it to your system, it usually sets itself as the default automatically, so you shouldn't have to change it. I don't have any default machine. I just want to pick this 1 turret 2 spindle, but it has a Y-axis. If you don't have a Y-axis, we can go through, that's something we'd have to look at and see how we machine some of this stuff because you might not have the reach, or we might have to make sure that the table, which we call the table, but it's really the spindle, we might have to force that to do more rotating than some of the other stuff. So for the stock wizard, the way I have my part set up, it is centered right here on XYZ0. And I have it tilted, so if I go to a top view from where I'm at, it's actually looking like this. And that's how I set it up if I'm doing a job for turning. But I also like to set it up this way if I'm doing a mill turn job. The important thing here is that we need to make sure we get the right origin. If you get some of the examples, and I can open one up, let's just go File Open here. If you use one of the examples that we have inside of the BobCAD folder, and actually these are the ones you would find inside of the help system. If you ever go through the help system looking for a tutorial on mill turn, these are the ones that'll pop up. What you could see, let me open up the right one. Yeah, like right here, this is just their 1 turret 1 spindle example. And when I open this up, you'll see when I go to a top view, we're looking down on the part. And a lot of the guys in our development team, that's how they set up the parts because there's no real changes you have to make. The way you're actually looking at this part file, or the way that your machine's looking at this part file, would be if you tilted it and we're looking at it like this. So there is our x-axis there, and there's our z-axis. So this one helps without, if you set your part up this way, you don't have to rotate your part at all. You really don't have to even mess with the origin. It's kind of just set it up and put it on there. But I find that doing it this way, how I have my part now and laying out the geometry, after I get my origin done, it makes it a lot easier for me because I'm working kind of in my standard view. It's kind of the view that I'm used to seeing at least. All right, give me 1 second. I'm going to take a drink break. All right. So now we're going to go in and actually create the stock. Now, this part's a little bit weird because when we create the stock, so I'll go to Stock Wizard. For the workpiece, we're just going to pick that solid model. And then I'll hit Next again. And right here's where we get to create the stock. Now, right now, it's making a rectangular piece of stock. That's the default. I want to go with cylindrical stock. But because I've reoriented my part, and again, it's not sitting like this, then we need to make sure we change our extrusion direction. So I'm going to say go to the x-axis. Now, if you use a bounding box, we're going to calculate a piece of stock that would match the size of a rectangular piece of stock, meaning we'd break everything into kind of a square. The problem with that is it messes up our center point and it doesn't include all the geometry. So if you ever have kind of it's not a round part, it's, you know, off center kind of, what you want to do is use a bounding cylinder. All right, the bounding cylinder is going to find that stock, and in our case, because everything's all centered up, it's going to center the geometry and make sure we have a piece of stock that basically overtakes, that's the word I'll say, it encompasses the entire part. So that's what you want to make sure to do. Again, that's just bounding cylinder, and then you're going to say calculate the stock. Now, the only other change I'm really going to make on the stock, I'm not even really worried about the facing material. I just want to add a few inches of stock on the back here because we are going to have chucks, or we are going to have jaws on our chuck, and I want to make sure that we're working next to those, not inside of them. So for my end face here, I'm just going to add, we'll say 3 inches worth of stock onto the back. So I'll be holding onto this, and then we'll do all of our work kind of up here. After we're done with that, I'll just hit the forward arrow here. And then we have to define the stock. Now, I think everyone has a different way of doing this. If I look at how Andrew does it and how I do it, it's a little bit different. Whatever way gets you the right orientation. The big thing is we need to make sure this origin, is square to the front. So if I go to just the top view here, once in a while, and I haven't had this issue in a while, it's not something that BobCAD fixed, it's something I had to fix myself, but when I'm creating my origin here, I need to make sure that this origin is square to that front face. If there's any sort of tilt to it, and I've done this on accident by picking a point that instead of being perfectly in line with what I'm trying to line up, it was off a little bit. It was kind of skewed. If you ever get an error when you go to launch your simulation or when you go to post your code, and it's telling you that the tool path that you're creating is not for a 4-axis machine. Now, this isn't always the case, but usually it's because the origin or a tool is not oriented correctly. So the first place I would look if I got that would normally be my tools, because usually what happens is I'll be doing, say, a cross drill, and I'll accidentally pick a tool that's set up for a facing drill. And so by doing that, it doesn't let me kind of it doesn't let me run it the right way. So you get errors telling you you're over traveling, or it's not for a 4-axis machine. Those are things that could happen, but be aware that it could be the tool, and other times it could be this origin. And this one's the toughest one to notice, because I've had it happen where when I set this up, instead of it being perfectly kind of parallel to that front face, it's got a skew ever so slightly, a degree or so. It's not much. Yeah. Let me copy this for you, Matt. Give me 1 second. I just got to send out this email form. Forward that right there. Right there, and I'll send it off to you. All right, you should have it here soon, Matt. And then, yeah, this is getting recorded. I don't know if it'll be uploaded this week. It's getting to the end of the year, so half the company seems to be out this week. But I will be getting this uploaded as soon as possible. All right, so after we have our stock set up and it's time to pick the origin, we have it set up so that the top dead center of my part is right at XYZ 0. And I do that mostly because then it puts the origin in the right spot by default. Again, I'm not accounting for any facing material. If I was, I would be back on this page. I would add some material to the start face. But I would just, square this side up before it gets on the machine, or run a quick face pass, whatever you want to do, however you want to do it. That's how we'll set it up. So I want to go in and leave my origin right at the dead center there. Using the boxes below, the X and really just the X and Y, I'm now going to orient it so that my Z is coming perpendicular from the front face of my part. So the way I do that is I say my X direction is going to point this way. So I'm just going to use this point over here. You could also draw lines, but this point, if it's lined up with that origin, I could say that's my X direction, and then I choose my Y direction. because if I get my X and my Y in the right orientation, then Z has to follow. Z is always going to pop into the correct position. So there it is. So all I did was pick that point back there for X, that point up there for Y, and the center point I didn't move, but it's right off of X, Y, Z, 0. The last change I'm going to make for the stock is my work offset Z down here. Most of you guys, or a lot of you guys with your mill turn machine, you're going to have the Machine Simulation Pro, which means you're going to see the chuck, you're going to see the full machine if you guys sent in the models for it and the posting team built it. So you will actually see the machine. So what I need to do is pull this part out of the jaws of the chuck. So for Z, I'm just going to say 3 inches. That's how much extra stock I added to it. So that should have something held onto the chuck plus pulling it out. And I don't know how long my chuck jaws are on this machine. They're usually an inch, maybe up to 2 inches. So I should have my part sticking out. If not, if the part's not sticking out far enough, we can always come in and change that value to pull it out a little bit more. Or go in and change the chuck jaw sizes, because sometimes they might be a bit bigger than you're really running. So when I'm all done with the stock wizard, we can go ahead and just hit OK. And there is the stock for the part. So if we look at our little cheat sheet now, we've completed step number 1. And from step number 1, we went right into step number 2. So we went in and actually set up the stock wizard machine setup. So step number 3 is let's do the stock material real quick. And that one's pretty easy. We just expand where it says stock. And right there we have the material. So I have aluminum. If we, by the way, I just want to point one thing out. Some of you guys may or may not have noticed. Version 34, up inside the settings here, if you go to the, I believe it's user interface. Yeah, right here. So user interface under the settings, you have this tree behavior option. Now in version 33 and previous, if you double click on something inside the CAM tree, it would normally just expand and collapse it. But now you could choose to have it expand and collapse or edit. So if you don't see me right clicking on anything today in the CAM tree, normally to change the material, I'd have to right click and hit edit. But with this version 34, you could just double click. So if you see something open and you don't see me right click on it, it's usually because I'm just double clicking on it. So just a heads up, again, that's just for version 34, but it works for all the CAM features. So if there's a specific tool path I want to edit, I can just go and double click on it and that'll fix it. So I'm going to use the 6061. I'm not going to change that, but remember, this is your whole entire group. There is no wood. I put that in there myself just so I could work with one of the customers at some point. But you got your all different types of steels, coppers, cast iron, super alloys, tool steel, titanium. So pick what you need. And then if it's the material you cut the most often, make sure to set it as your default. Another thing you can do is move things to your favorites. I feel like this is very underutilized for a lot of people. If you use 6061 all the time, go to it and click move to favorites, and it'll create a favorites folder and it'll move it into there. Be aware that when it moves it into the favorites folder, it will not be inside the original folder anymore. So it is a dangerous one if you're sharing the computer with anyone else and they might not know that you moved stuff to your favorites folder. So they won't look in the favorites folder usually. And then when we're done, yeah, like I said, I'm going to leave that 6061. So I'll just hit cancel for now. And there's my material. Now, the next thing I always do is blank out the stock. After I'm done making it, I really don't need to look at it anymore. The next time I want to see that stock, it'll be inside of the simulation, watching it get cut. So right now is the time where save it. Go ahead and give it a save. We're going to save pretty often today, just because we can. It's one of the safest ways not to lose any of our stuff. So we're going to save pretty often here. All right. So the next step we want to follow is let's go ahead and make our tools that we plan on using for this. So before I go and do that, I want to just take a couple measurements on the part, just kind of figure out what tools are going to fit, see if I'm going to have any issues with any tools getting into any areas here. So I'm just going to use the evaluate tab here. And I have a handy little pad of paper in front of me. And I'm going to go ahead and just start writing down a few of the tools that I'm going to end up needing. So for measure 1, I'm going to start by picking these holes here. I'm going to find out if these are all different sizes. So we got a 3/16, 3/16, and 3/16. So we're going to need a 3/16 drill. 3/16 drill. Perfect. We're also going to need a center drill. I primarily use, I use 90-degree spot drills. I like them a lot. I just like spot drills more than I like proper center drills. You can use whatever you want. This is a list of tools we're putting together now so that we can pick the tools and put them into the crib. So I'll use, I got a 1/2 inch, 90-degree spot drill that I'll use for that part of it. So also while we're here, let's go look at some of these radiuses. And this is kind of going to determine, what's the smallest tool I can use? What's the largest tool I can use? So if we just pick this edge right here, the big thing is we want to make sure it's an arc. The edge that we select, we want to make sure it reads as an arc, because sometimes it might read as a, as a spline. And if it reads as a spline, then we don't really get any sort of information from it. So we'll see that that's a 3/8 diameter right there. We then have up here a 0.4875 diameter. That's fine. Just looking at all of them, I feel like these are the smallest ones. So this should be, the rest of these should be pretty good. Not too worried about it there. So we're going to go with a, we could go with a 3/8, but a 3/8 is what barely fits in that slide. I mean, that's going to be a single pass. So I'm going to go with a 1/4 inch flat end mill. So we'll go 1/4 inch flat. All right. We don't really have too much machining that we have to do on the outside here, but that really depends on how you want to machine an area. You got to think with this side here, our part's not too thick. It's under an inch wide, probably about 3/4 of an inch wide or so. So I could come in with a tool coming from the front face and machine these flats and these little areas on the side. And that's what I planned on doing. But like this one here, this flat, you could technically have a tool that comes from, that's like a cross mill that comes in and machines that flat on there using the tip of the tool instead of the side of the tool. That is an option, but the way I see it is if I'm already going to be doing this curved side here, might as well just do the rest of it. Excuse me. So there we have it. I think that's all the tools we actually need. A 3/16 drill. We got our 1/2 inch spot drill to do the holes. And let's go ahead and we'll do one other big one. And let's take a measurement of this big hole on the inside here. And we'll see that's 875. So what we'll use on that, instead of using that 7/8, we'll go with a 3/4 inch tool. So we're going to go with a 3/4 inch drill that's going to drill that out. And then we can feed into that drill hole to pick up and clean up that area. So that'll be a 3/4 inch drill. And then I could use the same center drill with that as well. So not too many tools on this one. We'll have a few more on this one, I'm sure, because we got a bunch of different sizes, bunch of different entry styles and everything. So in here, we go down to our cam tree. We're going to right click on mill turn tools, and we're going to say tool crib. Now remember, the difference between your tool crib and your tool library is your tool crib is specifically the tools you're using for this job. Your tool library is where all your tools are stored. And for mill turn, we need to add adapters and then add our tools. So we need to make sure everything's facing the correct direction, which all of these tools should be pretty much parallel to the z-axis of our origin here. So they're going to be pointing at the front face. So we just need to make sure they're pointing the right direction. And so we'll go right into the tool crib. And so for this first tool, I'm going to go ahead and pick the 90-degree spot drill. Now, some of your guys' machines might have your positions. Maybe your even numbers can be live tools, odd numbers cannot. It just depends on the style of your turret. I'll say that, let's do the, if I have to move it, I don't know which slot is number 1. On here. So I'm going to add an adapter, and if I need to move it, I'm going to say for now that the live tools will be on station 1. So I'm just going to right click there and add my adapter. Now we have side mount adapters and we have VDI adapters. I'm going to just go to the side mount and say I want to use a face milling adapter and then hit OK. And it's going to add that tool into the system. Now what we have to make sure of when we do this is that we have the correct face. It's either set to the front face or the side face. The side face is the side of the turret. And actually, I'm going to put these on the even numbers. I want to put this, let me see what it looks like down here. Not really the way I want it. Actually, that's not, let me put that back on the side face. Okay, so we only have side faces on the odd number stations for this machine. So I'll do side face, so that's where we'll pretty much mount most of our stuff. So there's our face milling adapter for the, we'll say, spot drill. And then for station 3 here, I'll add in another adapter. Again, pretty much most of these will be face milling adapters. We don't really have any cross drills. I just need to make sure to put these on the side faces. So that one will be for our, we'll say, 3/16 drill. And then might as well, while I'm here, I'll just knock out all the drills. So add an adapter, side mount, face milling, OK, and then make sure we set the side face once again. And then for the final tool, so this is going to be the center drill, the 3/16 drill, 3/4 inch drill, and then finally we'll do our 1/4 inch flat end mill, which is really doing all the rest of the work. I'm going to use it for roughing and finishing. So if you don't want to use it for both, you know, maybe you have a roughing version of your 1/4 inch end mill and a finishing version, then you're going to end up having to put 2 of them in here. And it'll help if you pull one from the rough category and one from the finish category. But let me just go ahead and pick my face mill. Okay. And again, side face. So I have my 4 little adapters lined up. So now we can add tools to the adapter, and it's pretty easy. We're just going to right click on the face milling adapter and say add tool. And then we wait. And on the left, we have all of our drills. We have all of our milling tools right there, and then we also have all of our turning tools. We'll do a bit of turning in the next example, but I'm just going to go with my center drill, and I'm going to choose, I got a 1/2 inch 90-degree spot drill here. Before you bring the tool into the tool crib, though, double click on it. That will open up the tool parameters. Double check that everything that's defined is right, but really check what the tool material is. We need to know if it's, if it's high-speed steel, leave it high-speed steel. If it's carbide, make sure you set it up for carbide. That way, at least BobCAD's going to get closer to your feeds and speeds. It depends on, at that point, if you still want to use them. So I'm just going to pick my 1/2 inch 90-degree spot and then hit OK. Now, by default, it comes out with mounting orientation 1. That's perfect. If this was a cross drill, we would be in mounting orientation number 2. But since we're doing our face drill, that's where we'll put it. So there is the 1/2 inch 90-degree spot. Now for the second drill, I'm just going to add a tool. And for this one, we're going to just click on drill here. And then I'm just going to sort by my diameter. And I'm going to scroll down until I find my 3/16 drill right there. And should be long enough. These drills are usually pretty long anyway. So I'll go ahead and hit OK. Once again, that should be it. I shouldn't have to reorient anything. There it is. Now, the final drill that we're going to add is going to be that 3/4 inch drill. So again, drill. Another way to sort your tools, by the way, you can grab any one of these boxes, actually these filter boxes, but you can actually grab it and drag it up to here. And what that's going to do is it's going to group all of the same size tools together. And so if I go down to my 3/4 inch here, I only have one 3/4 inch tool. But if we were to go to something like the 1/4 inch, I believe, you'll see we have a 1/4 inch drill and an E drill. So it'll show you any drills that have a diameter of 0.25. And again, all you do, let me get rid of that. All you have to do is grab the column, drag it up to that header and drop it. And you could do that with any one. If I wanted to use the tool label, I could drop it like that and then scroll through here and find my 3/16 drill, or in my case, I'm looking for the 1/4 or 3/4 inch drill. I'm going to go with the diameter this time, or just sort by the diameter. Either way is fine. Pick your tool, double click on it, make sure it's the correct material. I'm going to switch that to carbide. I might not have that, but I'll hit OK. And there's my 3/4 inch drill. And then finally, we have the 1/4-inch flat end mill. So we're going to add that. We'll just say add tool. And this one's going to be under the mill section. I'll use the end mill rough category and sort by the tool diameter. And for this one, we just want to pay attention to a couple little things. The flute length that's on the tool. Notice we have 2 1/4-inch drills here. We got a standard and a long. The difference is the length of them. The flute length on the standard is 3/4 of an inch, which should be pretty close to what we want. But if our part's a little bit bigger than that, which it might be, we might not have enough. So I'm just going to go ahead and go with this 1/4-inch long. It sticks out 1 1/4 inches. I'm going to double click on it, make sure it's the right tool material, and then hit OK. Because if you don't set up the tool material here and now, you can't change it when you're going through your feature. And if you add a tool in and then later on realize you have the wrong the wrong tool material, you end up having to do a whole replacement. It's a big process. You have to take the old tool out, which if it's being used in a feature means you have to go into that feature, switch the tool with something else. Usually I just have a junk tool that I put in, or a tool that I'm not actually going to use, and I load that into the feature. That would then allow you to go into your tool crib. So if a tool is not being used in a feature, you can delete it. But if a tool is inside of a feature, it will not let you delete that tool because it's being used. So the whole process becomes more difficult later on, because now I have to go replace that tool anywhere it's used inside my CAM tree. I then have to delete the tool from the crib, open the tool library, make the changes to the material of the tool or whatever setting for the tool I want, then add it back into the tool crib, and then reassociate it with all the geometry. So best thing to do is spend some time double checking the tools here in the tool crib. I said it a few minutes ago, but one of the biggest steps to doing mill turn and not losing your head when you're doing it is making sure that when you're setting up your tool crib, you're setting it, as best you can right off the start. If you can get this all worked out right at the beginning, it saves quite a bit of headaches. All right, so now we're just going to go in now we're just going to hit OK and say that's our crib. One other thing about that, just so you guys know, if this is a set of tools that you're going to use often, or maybe you have a turret that I have 12 tools in here, so maybe you have a turret that 6 of the tools are always in the machine because you use them all the time. Something like maybe your center drill, maybe a 1/4-inch end mill, 1/2-inch end mill, whatever you want to do. You can add it in, and those tools would stay in those positions all the time. What you can do is down here, you can say save. All right, and then save it. It usually goes to the features folder, which is the best place to save it would be inside your BobCAD-CAM data folder. You go to your current version, and then right here you can go to your features folder. And then this is where I usually save tool cribs because it's a pretty safe place to put them. I'm not going to save this one now. Probably not going to use this too many more times after this. And then we'll just hit OK. So again, save it if you need to, or save it if you can, and go from there. So the first thing I want to do is I want to kind of look at some of the new functionality of version 34 along with this. Now 33 had this feature, but it was a little underused. I think some of you guys probably used it before. Others, maybe not so much. And it's the hole recognition feature. So I'm going to right click on machine setup 1 here and just go to hole recognition. Now, when I do this, it should read this center hole as well. We could either do that. There's multiple ways we could do that one. So I'm going to allow some grouping and just hit OK. And that's just going to pop up with all these different holes. So we could see it's drilling a lot of holes that we don't need. It's got a big counter bore on here. Pretty much treating a lot of this stuff like counter bores. For me, that's a lot more work. I got to go delete a bunch of things. So I'm just going to hit cancel. We'll just do them ourselves and call it a day. So we'll right click on machine setup 1. And so if you're using a live tool, all right, if you have a live tool like our 3/16 drill and our 1/4 inch, that's going to be a live tool. The 3/4 inch drill that I made technically can be done with a turn hole. So that's what I'm going to do. I'm going to say turn features and lathe turning. Now, selecting geometry on this, I should be able to just come back here and pick any point that pops up. Basically, I just want to pick where this chain ends so that it ends it. I didn't create my spun profile geometry yet. I still can, but I haven't done it yet. So I'm just going to hit OK and see what depth this thing reads. Or did I not pick? Oh, I picked the wrong feature. That's why I was having me pick that geometry. I got to go to lathe hole. I must have got a lathe turning. So for the geometry, once again, I'm just going to pick a point. Now, this lathe hole always goes down the center of the part. So I never have to worry about it trying to go somewhere else. All I'm defining when I'm doing this lathe hole is kind of where I want the tool to stop. So I'll hit OK and then hit next. And right here, we'll see that it picked the total depth of 3/4 of an inch. But what I'm going to do is I'm going to change the diameter to 0.75. And I'm manually typing that in because it doesn't read it off of the model. When we do the small 3/16 holes, it will read it. So we'll go ahead and just hit next. Right here's our strategy. So we have a center drill by default. But if we choose lathe hole up here, it'll give us a center drill and a drill. And we'll go ahead and hit next. For the posting, we got separate moves or CAN cycles. This really just depends on your post processor, whether or not it includes the CAN cycles for drilling. Most of them usually do, but definitely check it out. And next, again, we have our center drill. Now, when you're doing this, you always want to look to see if the tool number shows up properly. We always want to make sure that this is not a -1. If it shows up as a -1, it means BobCAD's making up its own tool, which I'm not sure why it is because we have a tool center drill. But we're just going to go up to the tool crib here. And a quick way to kind of see individual tool types is down here at the bottom left corner here. It's got the tool category. So you have center drills, and end mill roughs. I'm going to go with the center drill here. Pick tool number 1, not -1, and then hit OK. And that's going to be the center drill that we use. It's frustrating when BobCAD picks the wrong tool. It happens. Be aware that usually, or a lot of times, when you have a tool that matches the tool type that BobCAD's looking for in your crib, it usually picks that. I'm not sure why it kept that other spot drill in here, that other center drill in here. I'll have to investigate. But usually when you set up your tool crib before you start the job, one of the big reasons you do that is so that BobCAD can choose the tools that you enter, that you put into your tool crib. So there's my 1/2 inch 90-degree spot drill. And so we'll just hit next. I'm going to let BobCAD do the feeds and speeds on this one. For the parameters, now this is a 3/4 inch hole that I'm doing right now. So I could say that the center diameter is just going to be a 1/4 inch. And that should be plenty to seat, and it'll calculate the depth for me. Now, you could just enter in the depth that you want to go. So if you know the depth you want your center drill to go, enter that in. If you know the diameter you want when you're done with your center drill, then enter that in. Either way is going to be fine. I a lot of times use this spot drill. If I'm doing like a 1/4 inch hole, I'll use my spot drill to go, instead of going 0.25, go 0.26, 0.27 on the center diameter. And then when I drill my hole through, my center drill left me a little chamfer on the top of the hole. So it gives me a nice clean finish. That's how I do a lot of the chamfers I do for tapping as well. Now you have a choice of whether you do a single depth, so you're just plunging into, in our case, it's just an 1/8 inch deep and then coming back out, or you can peck your way in. I'm going to go with just a single depth here and then go next. Right here for our rapids. Now, the way I do this is I don't do this. I don't change these settings as often as possible. If these values work and they're not going to do any, give me any problems, I don't feel like thinking about them. I'm going to use the default rapid on the approach and the default rapid on the exit. And that's going to be the case for really most of my turning that I do. Now, with the why would we change these? Well, really, the only time I'd go back and change these is if I opened the simulation and saw a problem, which happens. Usually for me, it's when I'm working on the ID of a part. If I'm using a boring, a lot of times a skinny little boring bar, bring it into the center and kind of working my way out from the center. A lot of times I do make sure that I set my rapids to move Z then X. Just make sure they move the right way. So when you look at the defaults and you look at these other options, we have rapid on exit to the tool home and then X-Z. So that just means that X is going to move, then Z is going to move. Z-X means Z is going to move, then X is going to move. And then the ZX without the dash between it is an angled line. I'll have to see if I can find the picture from a few years ago, but a guy sent us an image, a picture of one of the parts where he accidentally set this option on there and took a big old boring bar on an angle through, I don't know, probably about 2 inches of steel. It didn't make it far. I'll have to see if I can find the picture. We'll post it on the forum or something of, the fun things that go on in a shop, the things that suck. So again, for now, let's leave it on the defaults. And if we watch the simulation and we see some sort of problem, we can go and change it later on. I'm not going to make a change unless I know I need to make that change. That's how I'm usually thinking about this. So I'll go ahead and hit next. For the MDI here, I'm not going to do any manual data input. So yeah, none of that right now. MDI is getting bigger and bigger. That's the little preview I'll give you guys for now, the teaser. It's getting bigger. So this is the center hole that we're doing here. So it is that 3/4 inch drill. Now it did pick the correct tool. It picked number 5, which I'm good with, but I never trust the system. Usually if it's not the right tool, it will say -1, but I always like to make sure I got the right tool. So I always go to the tool crib. I always like to repick the tool just to make sure I got the right one. And there it is. So when we're done, we'll hit next. Right, here's our parameters. So I'm going 3/4 of an inch deep, but whenever we do a drill in BobCAD, if we tell the system that it's a through hole, it will automatically add 50 thousandths onto the depth. So if you've ever noticed your drills look a little deeper in this page than they should, that's why. If you don't want us to add the extra 50 thou onto the bottom of the drill, just uncheck the through hole option and leave it as a blind hole, or just check the blind hole button. And that way we will leave it at whatever the depth is. Now, the effective depth is the depth at which we're going to get a full width cut, a full diameter, in our case, 3/4 of an inch wide cut. The overall depth is the value you're going to see inside your G code. That's the number that's going to show up, in the code. And it's the depth that we have, so it's our effective depth, plus the length of the tip of the tool. So it's also got that angle on it, and it's all factored in. With this one, again, you could choose to do a single depth, peck, or fast peck. For this one, I'll go ahead and say go ahead and peck that one out. Again, for the rapids, we're going to leave the defaults. And next, again, we have the MDI. No changes there. So when we're all done with that feature, you can hit, a lot of people always ask, what's the difference between finish and compute? For me, the biggest difference between finish and compute is I could say finish. I can go up to the top and hit save, give it a chance to save. And now if something goes wrong at this point, I'm not going to lose all my work. I can now come in, compute that toolpath. I mean, I haven't had BobCAD crash just on a calculation in a pretty long time, but that I can remember. But it does happen, and I've gotten burned a few times with 3-axis parts. It's usually 3-axis that does it, but I've gotten burned a couple times with 3-axis parts where I didn't save the work. I spent a bunch of time making all these tool paths. I didn't hit save, and when I hit compute, it crashed, or when I launched the simulation, BobCAD shut down and I lost all that work. So save as often as possible. There is an auto save option inside the settings as well that you can use. All right, give me 1 second. I need a drink. All right, now from here, I have my 1/4-inch tool, and I'm kind of thinking I might go make a bigger tool. Might go get myself a 1/2-inch tool that I can use to open up this pocket, and I can use to clean up the outside. It's just something bigger than my 1/4-inch tool. So I'm gonna do that now. I'm just gonna go to my tool crib, and on station 9 here, I'm gonna add an adapter. Same adapter, just the face milling adapter. And then I just want to add something, just a bigger tool. I could probably get away with, well, 3/4 might be too large because we just made a 3/4-inch hole, but maybe a 5/8 tool. Maybe go 5/8. So I'll go ahead and say add tool. And I'm going to choose the mill category and mill rough. Sort by the diameter and just get my 1/2-inch. We could go with the 1/2-inch standard there. It's a 1.125 flute length. So we'll hit OK. And there it is. So something to be a little bit rougher with. And we'll hit OK. Now what I want to do is I just want to take care of the leftover geometry, which I measured that center hole earlier. And it should be that value there. But let's just double check. Yeah, so it's 7/8. I now have a 1/2-inch tool. And I've already cut away, let's think, 3/4 of an inch. I have about 1/8 of an inch left, so that puts 1/16 of an inch on either side. I'm cool taking a 1/16 out in one pass, but what I got to be cool is taking a 1/16 out at that full depth. So it's 3/4 of an inch, and it's a 1/16. So there's a bunch of ways to do this. I could do this as a pocket, and we'll look at we'll do it. Well, let's do it as a pocket, and then I'll show you guys how to set up the leads for the finish pass. So I'm just going to right click here, go to my mill features, and I'm just going to do a mill 2-axis. From here, I'll say select geometry, and I'm going to start by, I'm going to open up this pocket to size first, and then we'll go and open up this wall to size. So I'm just going to pick that pocket right there. From the top, we're going to go from the front face right there. That's perfect. So that should be 0. That's good. And then we're going to go all the way to the back. So it should be 3/4 of an inch deep. If you want to go a little extra, you can. We did go a little extra on the drill, so we could go a little bit more. But we'll go ahead and hit OK. And next. Right here, we got our top of feature, total depth. Great. Next again. For the feature, for the machining strategy, I'm going to go with pocketing. And this will give me a pocket with a profile finish here. So I'll go next again. For the tabs, no real changes there. I'm going to leave that where it's at because I'm not going to tab a pocket. Next. Posting, we got our work offset number 1. Contour ramping only is applied to a profile rough tool path. So it just kind of shows up here. You may use it, you may not. All it's asking right now is when we do use that feature, which again, pockets do not have that. But when we use that feature, do we want arc moves to output or do we need it to come out in line segments? Then we have our posting mode. We have longhand code, auto y-axis, or polar interpolation. This is how the code posts. Really depends on how your machine handles it. So, and then right here, we're using the upper turret and the main spindle, which were also labeled right there. I didn't talk about that, but I'm only using one spindle today. So next again. Right, here's our multi-axis posting. Most of the time, you don't have to mess with this. This page follows the defaults of the actual machine. And so you don't really have to make too many changes here. There is some stuff, but that's kind of a as-needed basis, I would say. I'd say if you're struggling with some of these, some of this stuff, and you think it might have something to do with this page, give a call to tech support, talk to the boys, and just find out if this has anything to do with it. Once in a while it does, but usually there's other ways to fix it. So, get some help with that one. And then after you get it, you'll probably see what's wrong. So next, right here, it picked my 1/2-inch tool, which is perfect. That's the one I wanted to pick. But like I said, I always like to go in here, just double check, make sure it picked the correct, make sure it grabbed the right tool. In the right orientation. I've had it grab a tool that might be a cross mill instead of a face, so it'll give you an error later on. Right here for the patterns. Now, I like to use the advanced pocket. At this point in time, I really can't think of a big reason on why I would use a standard pocket other than it calculates a little bit faster. Basically, in the advanced pocket has the ability to, well, in version 34 and I think 33, Al can verify, we had detect open edges. Can't remember what version it came out in because it's in Rhino. It's in a bunch of the different softwares now. So I think it's 34. But we have this new detect open edges nowadays. Yeah, Al just verified. I think it's 34. So we have detect open edges. So I'm actually able to do pocketing. I got this tilted the wrong way. By just picking a floor and telling it to detect the open edges of that floor. And so for me, if I'm going to use a standard pocket, it means I can't ever detect open edges. It won't leave the part. Advanced pockets do, but it'll only do that if the geometry shows that that's there. Yeah, it's in our SolidWorks V9. It's new to V34 here, and it's in the Rhino V1 plugin. So the V9 is for SolidWorks, the V1 is for Rhino. And it basically takes our CAM tree and shoves it in those other softwares. So you could use your BobCAD-CAM portion in the other systems. So again, I don't really have a reason to use a standard pocket anymore. It doesn't let me do open pocketing regardless of what the geometry shows. And an advanced pocket does. An advanced pocket will do open pocketing if the geometry shows an open pocket. It'll also stay in as a closed pocket if the geometry is closed. So the geometry I just picked is closed. So that works out fine. I'm also going to use this button down here called Use Spiral for Circular Pockets. And another thing I like to change is my step over percentage. I'm going to go to, with this one, I'm going to just drop it down to 40%, but we might need to go a little bit lower to get a few extra passes in. Because one big thing about this is I should be able to reuse this pocketing toolpath that I'm making a bunch of other times around this part, just changing the depth for everything. So I'm going to go ahead and hit next. All right, here's our parameters. So I'm leaving this 15 thousandths for my finish tool to come clean up. I'll use my 1/4 inch tool to clean it up. We are taking 3/4 of an inch if we want, or we can go ahead and say multiple steps. We only got a 1/16 of an inch on either side of the pocket. So I'm just going to go with a depth of cut. Yeah, we'll do 3/8, just half of the depth there. For our leads, just going to plunge in. It should go to a spiral, so it should plunge down the hole we already made in the part, which is 3/4 of an inch wide. Sequencing, I always just turn on optimized. It really doesn't matter with a single pocket like this, but next. For the links, going to leave the standard. It's going to go direct for any links in the toolpath and between any groups. I'll just say direct. We don't have any groups, so it doesn't really matter. The addition or the advanced feeds, we can convert our rapids to feeds. If your machine has an issue called dogleg rapiding, meaning your rapids don't move in a perfectly straight line, they'll move on an angle, then a straight line, then you have an issue called dogleg rapiding. Even if you have that issue, a lot of guys don't notice it because it doesn't really hurt anything. Unless you have something above your part, or in our case with this type of, with the mill turn in front of your part, where you could hit like a fixture. If you have a fixture that you could run into, you'll definitely notice it. But a lot of people never notice it because it's just not something, it's just not something they need. It doesn't have any problems. So be aware it's there. We have fixes for it. Again, it's called dogleg rapiding. You could set up feed rates for your linking moves, which we really won't have any links on this one because we're using a spiral toolpath. You have adaptive feeds, and with this one, you only have a minimum feed rate based on the volume that the tool is encountering. And then finally, you have some corner slowdown options, really just part of the 2-axis. You can just slow down in corners to catch things up. It's a lot of big useful stuff for plasmas and lasers and water jets. So a lot of you guys might not ever use that. Finally, we get to the MDI. Nothing to add here. And then to the finish pass. So for the finish pass, it's got the wrong tool. And the reason it's the wrong tool, even though this tool matches all the information that my other tool has. The reason this is the wrong tool is specifically because of the category it got pulled from. If I take a tool from the roughing category of tools, it's going to be labeled with rough. If I take a tool from the finish category, it's going to be labeled as finish. They could be the same tool, though. There's no real wrong way of doing it. So I'm just going to go to the tool crib. I don't have any end mill finishes, so I'm just going to go to my end mill rough, and I'll use my 1/4 inch flat end mill to clean that up. So I'll hit OK, and there's my tool. This is just a finish pass. So the only changes I'm going to make, I'm going to let BobCAD do the compensation for me, but I'm also going to set up a G41 so I can recomp at the machine if needed. Next. For the parameters, I'm going to go full depth, 3/4 of an inch, no allowance. I just want a nice clean wall all the way through. Next again. Now for the leads. With these ones, I always like to set it up so it plunges right down the center, feeds over to the wall, makes its cut, and then comes back to center. And you can do this real easy if you know the diameter of the hole that you're working on, which right there is the diameter. So I'm going to do a right angle lead. For the length, I'll say 0.875. That's the diameter of the hole. I'm now going to subtract my tool diameter, which is 1/4 of an inch. So we're left with 5/8. Now that leftover 5/8, we're then going to just divide that in half. So divided by 2. And that length right there should put us right into the middle of that hole when we get there. So next, we have our corner types, no changes there. Machine sequencing, just going to turn on optimized. Advanced feed rates, once again, no changes. And finally, the MDI. And when we're all done, we can hit compute. And let me rotate this guy around. And let me blank it out so we can see it individually. So there's our pocket, little quick kind of pocket. And you'll see with, what did I go, 40%? I might want a little bit more than that. So if I go back in here, let me just go to, we'll go 20%. See if we get a couple extra passes. There we go. So we got a nice spiral entry. It's going to open us up to this size here. And then here's our profile finish right there. So we're going to come right down the center, feed over. Now, what we may need to do, depending on how we're running our machine, we may need to move this start point because right now we're on the other side of our machine axis. So for it to cut there, it all depends on your posting types. But to change the start point of a piece of geometry, right here you'll see where it says default chain start point. And it's starting there because that's where the arrow is. I'm just going to right click on that and say modify. And then I'm just going to click the opposite side right over there. Hit OK. And then I'm going to right click on my feature 2 axis and compute all toolpath. From there, you'll see there's our pocket. And there is our profile finish on the other side. That right there could be a reason that you might get an error telling you that you're out of your machine axis, you're over traveling, because it was trying to go basically Y negative or I guess X negative when we could go X positive and then let the part turn. So again, it depends on how you're running it. I'm going to go ahead and rename these just so I can keep track of them. That's going to be the center. Well, let me turn on my caps lock. Center hole resize. And that's what I'm going to label that. Now, I just had someone, I did one of my seminars last week in Charlotte, and someone in the class asked about spring passes and how you do spring passes. And we don't have any specific feature for spring passes. Basically, your spring pass is just a couple extra finish passes. You refinish the same area a couple times so you can, slowly fix the deflection that happens on your tool when you're cutting. So what I could do is take this profile finish here, and I like to just copy it. And then right click on the profile finish again and just say paste, and it'll put it right under that. So now I'm doing 2 finish passes. I'm going to do 3 finish passes total, and I just have to go in and compute the other 2. They match everything exactly the same. So we do our pocket and then 3 finish passes. Now what I'm going to do is I'm going to copy this whole thing. So I'm going to copy the entire job or the entire feature, and I'm going to right click on machine setup 1 and paste it. It's going to ask if I want to use the same top and depth. This is kind of unless you're keeping the same depth for sure, hit yes. If you're changing the depth, it doesn't matter if you pick yes or no. During your geometry selection, you're able to go in and reset the top apart and reset the depth of cut. Or reset your total depth. It's up to you. Again, if you're keeping the same depth, always hit yes. But if you don't, if you're picking a new piece of geometry with a new depth, it doesn't matter which one you hit. So no. And for the geometry on this one, it's going to be this arc out here. So before I go and do this, I just want to jump up to the Evaluate tab, measure 1, and just take a measurement of that geometry right there real quick. And that'll give me my diameter so I know how to set up my leads. I'm also going to call this the center hole counter bore. So I'm just going to rename this feature. And we'll just say C bore. And there we go. So the geometry, I'll say reselect. It's going to go right there. Since I'm here and I already know that it might pick the opposite side, I'm then going to go to my chains and make sure I put my start point on the opposite side where I want it. And then the top is going to be the surface. I always recommend if you're going to pick your depths, if you're picking off the model, pick your top, pick your bottom. That way your depth for your bottom is in accordance to where you picked your top from. So pick bottom. I'm going to pick this edge. And when you're picking geometry for your depths, it's any bit of geometry. It doesn't even matter if it's the right area you're working on. If I have another pocket on this part that's the same depth as what I'm trying to pick right now, I can absolutely go pick that. I'll go ahead and pick it, and we'll see. It is actually a 1/2 inch, so the default value there was the right number. So I'll go ahead and just hit OK. And then I'm just going to edit my feature. And then just go through your settings. But this time you should be going a lot faster. Really all I'm looking at is the toolpath. That's still all fine. I may change my step over. I probably don't need to. And then the other thing I'm going to change is the leads tab right here. So I now have I'm still using my 1/4 inch tool, but I'm going to go in and say 1.125 minus my tool diameter. And that's going to give me 0.875. And then I'm just going to divide that by 2. And then I like to copy and paste. It doesn't really matter because we didn't change anything here. But be aware that if I was to go in and set a ramp entry on this with a lead in, if I was to say apply to all operations, it would add a ramp entry to every other feature. For us, though, we should be able to just say apply to all operations under plunge here. And that's going to take the leads that we set up there and copy them to the other profile finishes. But it shouldn't do anything to the leads page for the original pocket because there wasn't anything to change. When we're all done, we'll just hit compute. And there is our pocket. So let me blank this out and we'll see here's our pocket. Which ones? Oh, I forgot to blank out the finish pass. There they are. There we go. So here is our pocket. Just going down, cleaning that up. We have our profile finish right there. Second profile finish, third profile finish. So little spring passes as well. So now that we have that done, the next step is going and kind of figuring out this outside floor right here. Now, I like to use an open pocket when I do that, but I don't want to try and say detect open edges because there's a lot. Like this little pocket here and these little cutouts here, those will be fine for the detect open pockets. But I want to go and get my geometry off this. Now, we oriented our part kind of sideways. So if we go up to a top view, we're looking down on the side. So if I want to get geometry off, I want that geometry to project this direction, not the top plane like we are now. I want it to come off the part this way in accordance to the Z that I have on my machine setup. So the easiest way to do that is I'm going to go to a side plane, just like so, just like that. Now I'm going to go and make a new layer. All right, have a good one, Ulrich. It's probably getting late for you guys, right? All right, bye. So I want to add a new layer to this. I'm just going to right click, add a new layer, and I'm just going to call this open pocket. Simple. I'm then going to go and kind of cheat this a little bit. I could extract one of these edges, and looking at it, I think I could get away with using this edge right here and just turning it into a full arc. Actually, that'll work perfect. Another way to do it, I'm going to do it both ways, I think, just to show you guys. If I right-click on my stock here, or sorry, if I right-click on my machine setup, all right, and say edit, it brings up all these points that we have on the part. One thing that I can do is I could click this button that says keep bounding geometry. Again, you make sure you have a new layer first, but then you say keep bounding geometry. I didn't change anything else. I'm just going to cancel out. And if I turn off my CAD layer, I'm left with all the geometry it gave us from when we made the stock. So it's that perfect arc. And this is good for us because now I know exactly where my stock is. I'm now just going to get rid of the extra stuff, which is all of this stuff right here, and then all the extra points that we have. And to pick the points real quick and easy, I like to use the selection mask here on the left. Yours might be down at the bottom or even on the right. But if we click this no mask button right here, it turns off all of the it turns off all the selections. So if I drag a box, nothing happens. If I turn on that point right there, that point mask, and I drag a box, it picks just the points, which I can then delete. So the next thing I want to do is that gives me my outer edge. I'm now just going to go and extract this front edge right around there. So I'm just going to go create 2D, extract edges, and I'm just going to pick that edge right there, hit OK, and cancel out. Now for me to define my own open pocket, what I need BobCAD to see is a dotted line on the edge where it's allowed to leave. So I'm just going to grab my select tool here. I'm going to pick this larger of the two arcs. That's the outer boundary where I'm okay with the tool leaving. I'm going to right click, go down to modify attributes, and then change the line style here to a dotted line. It doesn't matter which type. Excuse me. We just need to pick one of them. So I'm going to pick that there and hit OK. And then if I cancel out, I'm not in any feature. That right there is going to be my open pocket geometry. So I should be able to use this to take the entire part down to this floor level here. And I should be able to do that with the same toolpath. So I'm going to copy my toolpath I made. I'm going to go ahead and paste it. And once again, it's going to ask me if I want to use the same top and depth. No. And then for the geometry, I'll say reselect. I'll turn off my CAD layer with the solid model, and I'll just pick the two pieces of geometry. Again, we do want to look at the start points for these. This bottom one shouldn't have a start point. It shouldn't be using a finish pass. But again, let's just make sure we have them both on the kind of far side of the job. And the other thing to look at is this guy right here. If we look at the direction it's cutting in right now, we're compensating all of our finished stuff, or especially our finished pass, to the left. To the left would put us on the inside. So I would expect to see, if we were to calculate this, we'd end up with a pocket that has the finished pass on the wrong side. So I'm just going to click the tip of this arrow here, so that to the left will put me on the outside of the geometry, which is, the outside of that wall. And then I'll say pick top. Top's going to be right there. Bottom is going to be this edge right here. Doesn't matter which edge you pick. It's just an 1/8 inch deep, it looks like. We'll hit OK. And then we'll go ahead and compute that one. And there it is. We're doing it in one pass. Don't know where it's starting. Looks like it might be starting out here. I'd have to find out, see where it's all starting from. The other change I could make is the lead in for the finish pass. Let me hide all this stuff and look at it. So here's our finish pass. There's our lead. It's a 90 degree lead in. It's a right angle lead. It's not a bad choice, but it could leave a mark on the wall. I just want to go in and edit the profile finish here. I'm going to go down to the leads tab for it, and I'm going to go with a parallel lead. I'm going to make it a little bit longer than I need to. I'm going to go, I got a 1/4 inch tool here. I'll set it up for a 1/2 inch. And again, I'm going to apply that to all the operations so that all these other leads pages match it. So when I hit compute now, there's my lead in. And so it's going to lead in nice and tangent It's going to cut around and then lead out nice and tangent. I might have done that backwards. Yeah, it's going to lead in, cut around, and then lead back out with that parallel. So we just need to rename that. That's going to be the open pocket. That's 0.125 deep. And that's going to be the floor of that front face now. So we'll shrink that up, and there we go. Now we could go start on some of these other pockets, but some of them might have some geometry that we need to extract edges for. Let's start by getting this whole kind of crooked pocket here down to this first level, because then we have individual pockets. So we're going to take the whole thing down first, and we'll call that our C-shaped open pocket. So add a new layer. We'll say C-shape, C-shape, I can't type, open pocket. And this time when I go to extract my edges off of here, I'm going to do it using a lot more geometry, and I'm going to have to clean it up. So again, I need to make sure I have my UCS on a side plane. That's going to line me up with my front face. And then I'm going to go to Create 2D and Extract Edges. From here, I just want to lift this off a little bit. I actually want to pull the wireframe off a little bit. So I'm going to say my Z is going to go to 1 inch. So this is actually going to project to 1 inch high above the part. It's not a big deal, though. We could just make changes later. So I'm going to go in and just pick all of this geometry for the floor of the pocket. It's going to give me more than I need, but it's going to give me the entire shape. All right, when I hit OK, again, it's going to project all that geometry up to there, where I can now cancel out, and I'll just hide my CAD layer, and there we have it. So using Quick Trim now, so under Utilities and Quick Trim, I'm just going to go trim away any of the extra geometry. And be careful with this one. We need to make sure to do a cleanup, optimize afterwards, because we are going to end up with some duplicate pieces of geometry. So a lot of these might have some duplicates, mostly the stuff in the middle, but just beware. If you think there might be duplicate geometry, get rid of all your intersecting pieces of geometry first. Go up to the cleanup optimize, or let me rephrase that. You don't have to get rid of that geometry first. You could run cleanup optimize whenever you want. Anytime you got 2-axis or 2D geometry, wireframe geometry, run this thing. If there's a problem, it'll fix it. If there's not a problem, it's not going to do anything. So now I'll just drag a box over the whole part, hit OK, and we'll see it fixed 11 pieces. Now, when it says it fixes that much, it might be duplicates. There could be duplicates. It could also be that there's broken entities in the job. So be aware of that. So I'm just going to go in and pick this end line right here and right click, go down to my entity modify here and change the line style to a dotted, because this is also an open pocket, and this is where it's allowed to enter and where it's allowed to exit. So once again, we'll go over to our CAM tree, and I'm going to use the same features I've been using for the open pocket. So I'm going to copy this, and I'm going to go ahead and paste it. Now, before I go and pick geometry, I want to go and repick I got to go repick the tool and rename this. So let's rename it first. This is going to be the C-shaped open pocket. So let me pick all that. And then we'll go C-shaped open pocket. And then I need to change the tool. I took a measurement of that gap. It was about 3/8 of an inch. So we cannot use a 1/2 inch tool. I'm just going to go to my tool crib, and I'm going to pick my same 1/4 inch flat end mill, and that one should work. I can use the same step over amount, 20%. That should be fine. And again, even if you use spiral for circular pockets, that's only going to come in when there's a circular pocket. The only other thing I really need to check on is the leads for my finish passes. And the finish pass that I used before with the parallel leads, perfect for 2 straight walls. I don't need them to be that big. We'll set our length up at just 1/4 of an inch and apply to all operations and then finish. So the big thing here is now when I go to pick my geometry, so I'll right click, say reselect. I'm just going to hold shift on the keyboard and pick any one of the lines for this C-shaped pocket. And there it is. from here, let me go back to my top plane. From here, I can tell that the top is no longer here. We've machined the part down to this level, and the total depth that I'm going is down to this level here, to the top of these two bosses in the middle of the pocket, like so. And when we're done, we can hit OK, and then right-click and compute all toolpath. Now, I may need to go in. I got a 1/4 inch tool. It's taking a 1/4 inch depth of cut. I might want to go in and change that. So let's go edit this. Let's do it in 2 passes. So first things first, I'm going to go to the parameters page and do multiple steps. The other thing I'm going to do is I'm going to change my step over. I want to go down to like a 10% range and then recompute. So hopefully we get more than the 2 passes we were getting in there. So now that's a bit less aggressive on the tool. We have our pocket, our profile finish, the first, the second, and the third, and they're all starting hanging off the part over there. Beautiful. Go ahead and blank that out and shrink it up. And then really we can use that same feature to do all the rest of these pockets. So I'm going to copy this feature. I didn't take measurements on the depths for all of these. So if we want, we could go and measure this line on the wall here. We'll see that one's going down 0.1875, so 3/16 there. That one also going down to 3/16, and this one also going down to 3/16. So I should be able to do this pocket, and this pocket at the same time. So I'm going to do that first. We're going to copy the C-shaped pocket because it now has the right 1/4 inch tool. So we'll copy that and then paste it. Yep. And I'm just going to come in and edit the name again. This is going to be my 3/16 deep pockets. And for the geometry, I'm just going to say reselect. Now for this one, I'm not picking edges. I'm going to pick the surfaces themselves for all 3 of those pockets. The other thing we want to double check on is that the detect open edges function is turned on. Now, if you're using version 33 or anything previous to this, you're going to follow the same steps we did for all the other open pockets where we had to edit the edge and make it a dotted line. All right. The only thing I need to make sure of is that my pick top, I'm going to go right off the top here, which I believe is already set. And then pick bottom, just going to pick the bottom edge right here. Perfect. Didn't get it. Pick it again. There we go. So there's our 3/16. So I'm just going to hit OK, and I'm going to go ahead and compute that and see what we get. It should go over the top of those holes just like that. So there's 1, there's 2, and there's 3. It's broken into 3 separate tool paths as of now. You could change that if you wanted to. It doesn't really matter. We could then take all these. Basically, we're using this same pocket. We're going to copy it, shrink it up. Right there, and then we're going to go do our other pockets. So I'll go ahead and paste my feature, and yes, I want to take some measurements of this one, and so we'll see this depth for that pocket there is a 1/2 inch. Whoops, right there. We'll see that this one over here is also a 1/2 inch. The pocket on the inside of this is 3/8, and I believe this floor is also 3/8. Let's look. Also 3/8. So we're going to have 2 more pockets. One here that goes to that 1/2 inch deep, and then these 2 will be their 3/8. So I'll go ahead and do the 3/8 ones first because it's a quicker rename. So 3/8 deep pockets. And again, for the geometry, we'll say reselect. Pick the floor. Pick the floor. We'll go in, we'll pick our top, and we'll say that we've already machined this down to here. We just need to go down to there. So we'll hit OK. Now this one, we might need to come in and make one settings change, which is on the leads for the pocket, the ramp entry here. So we can ramp down instead of just plunging in. It just depends on what you want to use. The other thing I'm going to need to change on this is the leads for all the final finish passes. I'm going to follow my rule of thumb, which is use half the tool diameter. So I'm just going to set this to 1/8 of an inch and say apply that to all the operations. And you know what? Let's do a circular lead. So we'll do 1/8 inch by 1/8 inch right there. And if we get the start points in the right spot, that shouldn't cause any problems at all. And just hit compute and see what we get. This one ends up just being a lot of copy and pasting toolpath. So you can see the lead is right at the limit there. That's about as far as we want to do. So we can right click on that feature. Let's edit this. So again, the rule of thumb for leads is use half the tool diameter. But if you're already compensated with the system, then the tool's already got a little extra space. So I'm actually going to take these and just divide them by 2. Do some little 16th inch leads for the center or circular leads there, and then compute, and that's going to make them a little smaller. So now I'm plunging into the middle after the other geometry's already been kind of cut out of there. And then finally, I'm going to copy this toolpath and paste it right there. And this one is going to be the 1/2 inch deep pockets. So 1 divided by 2, deep pockets, reselect. Going to pick that there and pick that there. This one has had a cut done. This one has not. So I'm going to start at the top. I might cut a little air for that first one, but I'm not too upset with that. So we'll pick that there and then hit OK. And finally, let me blank these guys out. And finally, we'll go ahead and edit our feature. The only other change I got to make on this one is the leads again. These could go back to being parallel because it's straight walls on the outside. And then got to add that to all the operations and then compute. And there is our 2 pockets. All right, so the last kind of 2 things we got to do. I haven't drilled any of the holes yet. So let's knock that out real fast. I'll just do my mill features, mill drill hole. I'll select the geometry and just pick the inner walls for all those holes. Just like that, hit OK. And then there they are, 3/16 total depth. It's set to a through hole. Really not going to do too much here. I do want to make sure that the top is set. I'm actually, with this one, they could be they're different heights. No, they're all at the same height. So I'm going to say pick top. The top is going to be right here because that's where all those floors are set to, which I believe is the right height. And then the total depth is going all the way through. So that's perfect. For the sequencing, I'm going to choose hole, which gives me that center drill and a drill. Optimized, posting, pretty much the same thing we saw on the drill earlier, other than it still picked the wrong center drill for me, but we'll pick that one. Got our parameters. Yeah, we'll go 160 deep. The thing we need to pay attention to is really when we're done with this, are our linking moves safe? You can see we're going over the part, but it's raising up 200 thousandths from our surface. That's our rapid plane right now. So that means we're only 20, 25, 15 thousandths above this surface. So if we want to make that a little safer for our own sake, I'm going to edit my feature. And right here on the rapid plane, I'm just going to I'll just make it a 1/2 inch. And then hit compute. And that's going to raise it up a bit higher. So we're not rapiding right in front of the part there. And finally, the last bit that we have to do is going to be these pockets here. Now, you have a choice with this, especially with the fact that we made an open pocket. I would probably make this an open pocket again. So let's rename this layer, add a new layer. We'll call it outside open pocket. And we'll shrink that up. And now I'm just going to take this wireframe geometry that we have for the outside, and I'm going to go to home and copy, and then cancel out, hide that layer. And on the new layer with our check mark on it, I'm just going to go to home and paste. From there, I'm going to use our CAD model, and I'm going to extract our edges. So again, I need to turn on my side plane. And that geometry is sitting at Z0 right now. So when I do my projection, I need to make sure it goes to Z0. And then all I'm going to do is pick the bottom line there and the bottom edge here. And this should all just get projected directly up. So just like that, on the correct layer, we'll hit OK. And then we can turn off everything else. And that's what we're left with. So now I can use my quick trim tool to trim out anything in between those geometries. And the final change I'm going to make is I'm just going to take the outer arc of both of these, right click, modify attributes, line style. I'll go dotted and hit OK. And the last step is, once again, we should be able to use that 1/2 inch tool and then the 1/4 inch tool, which is what I used for these two. So I'm just going to copy those original ones. And then I'm going to right click and say paste feature. And yep. And we're just going to rename this outside open pocket. And then for the geometry, they're all going the same depth. So we're going to go there and there. For our CAD, we're now going to say, let's start at the top. So we'll start at the top and we'll go all the way to the bottom. And I'm just reaching through, grabbing it from there. And so we'll hit OK. And that should be it. We're just going to right click on that feature and say compute all toolpath. And there we have it. So it's been a while since I've saved. Let's go ahead and save, because that's going to be a problem if we don't. And there we're left with everything. Now, the only thing I would want to go change potentially, we're leading out okay there. Let's go with some different lead outs on that. I'll go with, let's see what parallel does. So apply that to all. The only one I'm worried about not being able to do parallel is this one, but that looks good. Yeah, that's what we want. So now we're starting off the part coming in. They're probably longer than they need to be, but good enough. So save. And let me shrink that up. So there's all the tool paths. I believe we have everything. Now, when we launch our simulation, a lot of people know this, a lot of might not know this though. If the solid model is turned on, it will automatically, no matter if you have a workpiece selected or not, it will show up inside the simulation. If you have a workpiece or a solid model turned on, it will take longer to load the simulation because it's loading in a copy of our solid model here. So I'm just going to go ahead and say start simulation and cross my fingers that I don't get any errors. And I thought I might, so that's on the center drill for this one here. And it's probably because it's reaching across the part and it's over traveling in my, I don't know, my x-axis it's saying. So I'm just going to turn that off for now. I just want to do a post yes, no on that. I just want to see if it'll simulate everything else. Center hole, resize pockets. All right, so my travels for this machine are small. Right there. Let me just do this, cancel this. So I have to tweak the machine. This isn't the right style machine, but if we right click on here, we can backplot this stuff. And you don't see the whole turret or anything, but I'll figure out what's going wrong with this during lunch and make sure it works right there. So this will let us come in. We are not pecking those holes. Okay, good. So we're not pecking the holes, just going in, cutting all that. Pretty much everything else you could go in backplot for now. I just have to figure out why we're getting the errors. Could be some setting on my system. I want to look at the outside ones right here. And so for that pocket, we'll say backplot, turn it up a skosh, and then we'll say play. And it's going to come in and just chip its way out. Now, doing the open pocket, you're telling the system, it knows how much material's there. It knows what your step over is, and so it's just going to work its way in from there. So there we have it. And then we'll go ahead and close it. So yeah, I'll figure out what's going on with it during our lunch break here. I could start by going in and just pretty much turning off everything and then turning on one toolpath and seeing, does that one work? Yeah, no errors with that one. So it's just going through and kind of figuring out which one's causing the problem. Could be any one of them. I mean, it'll tell us when it's wrong. So this is what happens when you have the solid model or a workpiece set up. It does take longer to actually load the part. If I say run, we can see we're just going to come in and do our drill down the middle. Pretty easy. I'm going to remove my workpiece. I'm going to hide my model there. There we go. So I know the hole works. Let's go ahead and see if we can get the center hole resized to work. So yeah, we're hitting our machine axis limits right there. X is, okay, so if I go there, edit this, posting, let me just do longhand code for now. Compute, does that change it? About to find out. Let's see, we'll save that. And then does that let me in? Okay, so I gotta, for this machine, I might have to use longhand. Because this is gonna change if the machine's rotating or not. Why is it zooming in like that? What are you doing? Show me my machine. All right, so there's my machine. I think I got enough of the parts sticking out. We'll find out. And I'm going way too fast. Sorry, guys. There we go. That should slow it down. All my tools. Oh, tools are turned off. We could show those. There's all my tools. I don't know what I was doing. Last time I was in the simulation, I turned off a bunch of stuff. So there we go. So now we should actually see the tools run. Center drill. We're just opening up that pocket. Those ones there. Definitely got to be careful. We should be fine. Yeah, okay, good. So I got to go in and set up all these things to use the longhand code, and hopefully that'll be enough. Might need more for the drilling, but let me set these to longhand, compute, and that one can go next. Edit that one. Posting, longhand, compute. Had I done this at the beginning and not, well, and because I copy and pasted, we got to deal with all this now. So compute, that one will take a second. These other pockets, let's try this one. Longhand, compute. All right, so we'll go ahead and hit save, and let's see if we can start our simulation this time if we still have the over travels. There we go, looking better. All right, so there it is. So I want to get it. The mill turn's a tough one to get a good view of the part. Notice I have all this machine around here, though. If you do have a big chunk of machine kind of as the back, I really only care to see the spindles, the turret, and really that's it, and the tools. So if you go to toolpath rendering here, if you're on the machine mode and you can see the whole machine, go to visibility and then machine housing, and you can actually hide that whole thing, so it'll disappear. Mill turn's one of the most difficult ones to line a good view up with, I feel like. So I'm just going to keep it kind of slow right in the middle there. A lot of times drilling happens very quickly. So I'm just going to go ahead and say run. And we have some ordering issues going on here. So we'll have to fix that because we did all of our center drills. We're probably grouped right now by individual tool. So it's using the individual tool. So it's try to keep the same tool running as long as possible, which a lot of times that's going to be used for doing, if you didn't have a tool changer, which not really the case when we've got a turret here. So let's fix that real quick before we get too deep into the simulation because we got a bunch of gouges happening. And so machining order is super important. If you don't know about it, if you go up to your settings here and you go to system and then CAM, wait, no, it's under documents. Sorry, document default and then CAM, you actually have your default machining order. And so for my mill turn job, I have it set to individual tool per machine setup. But the way that I programmed this is the way that I want it to run. The way that I set it up in the CAM tree there is how I want it to run. So to change that, we just right click on our mill turn job and go down to machining order. And what you'll see is the center drills grouped together and basically trying to use tool number 9 here as much as possible. So I'm going to say individual feature, and we'll see this switch around a bit. And so now we're going to do our center drill, then our pockets, and then down at the bottoms when we're doing that other drill. So we'll hit OK. And again, reload the simulation. If I turn my CAD model on, when I go to load the simulation, that will allow an option in here called the workpiece to be used. All right, so the workpiece is found under visibility. Yeah, I'm just waiting on it to load here. So you'll find that under visibility and then workpiece. And you can actually compare the part that you're cutting here in BobCAD to the workpiece. So I'll go ahead and say run. And there's our center drill and drill. Now that we have everything going in the right order, should come out quite a bit better. There's our finish for that, 3 finish passes. And we open up that counter bore. And we could use a turning tool to do some of this work as well. Same with like that right there. I could have turned that in with a CNMG and then maybe done just a cleanup pass with a sharp cornered end mill. Just depends on how you want to set it up. There it is. We're doing our pocket. We're not going out of the pocket though. Yeah, we are. Okay. I think we got some work to do on that C-shaped pocket that we had there. Doing all those cuts, finish passes. I got something strange happening. Oh, we got a gouge through the middle there. Don't know what the collision is there. That's the stock. It's saying. Might have a start point going the wrong spot. And right there. Okay, so it did finish that pocket correctly. We really only have the one gouge in here, and this was giving me a weird finish because I hadn't done that outside cut yet. So I want to take that outside cut and move it above the C-shaped pocket. So I'm just going to grab it and drag it to the open pocket here, or drop it right in the middle. So now it's going to do the outside, then the C-shaped pocket. Now, you always have to reload the simulation if you want to. If you reorganize anything, you got to reload the simulation. So I'm going to give that a save. The other one was I believe the 3/8 deep pockets. These guys here. And we had a gouge. Yep, there it is. You could see it right there. Totally didn't see it when we did it. So we're just going to edit our feature. And we're going to look at the bottom, the top of feature right here. A lot of times what I do to make sure I still always have a 200 thousandths rapid plane, if you have a negative top of feature, you can actually just come to the rapid plane and say plus whatever that negative value is. So 0.375, that should now lift me up 200 thousandths above the front face of the part. So again, I'll compute that. And now we'll see our finish passes are going through that location. One other small change I'm going to make. Let's go ahead and edit where this start point's at. Right now it's trying to start right in that corner. I'm going to move it to this inside edge there. Hit OK. And compute all of the toolpath. Excuse me. Now we'll go ahead and save it. And I believe that's everything. I think that took care of all the problems. So let's go run it one more time. Start simulation. Now let's see where we get. All right, so it's loaded up now. If you want to see just the part and the tools cut, you can turn off the whole machine by just going to workpiece stock here. The arrows will designate which way you're turning when you're making your cuts. So we'll hit run. And here we go. Open up that pocket there. Get that outside open pocket done. Couple finish passes. And then we're going to take out the outside first, because that's what we were running into a minute ago. Was it was basically seeing stock there still for that C-shaped pocket we were doing. And now we clean it up. That looks a lot better that time. I believe we fixed all the rapids on this now. Looking good so far. Okay. Clean those up. Then we come in, we clean up those pockets there on the inside. Let me turn this a little bit. There we go, so we can see them. And we're going to take that one down a bit more, down a bit more. Finish passes. Drills. Drills are okay, other than the fact that that 1/2-inch spot drill we got's a little big. So that's a quick change. We just have to swap out our center drill for something a little bit smaller. So let's just do that. We're going to right-click on the mill turn tools here, go to the tool crib, and then for that center drill, right here under station 1, I'm going to right-click on it and say change tool. Now it's saying, hey, this tool's already in use. So do we want to make that change for all the features that use it? Yes, we do. And so we're going to change our tool. I'll use this 1/4-inch 90-degree spot. That should be fine. It should be smaller now. And we'll hit OK. Once again, save. And we'll start our simulation. So this will be our final simulation, and we'll break for an hour for lunch, and then we'll come back at 1 o'clock, go from 1 to 3 or around. And yeah, if you guys have any questions that come up in the meantime, it could be right now, it could be during lunch, let me know, and I'll try and answer any questions I can. So we'll speed this one up quite a bit. We've seen most of it. Most of it seems to be working. We're just trying to make sure the final results look good. Now, one thing about, getting your final results, make sure you always do a full simulation. I don't care if you run it as fast as you want to, as fast as possible, but run the whole simulation. If you just go and fast forward through it, we're not actually doing any sort of gouge checking. So you could end up getting some errors that you might not notice, little things. So there we go. Drill it. Now, with the workpiece, with that CAD model turned on, I can now turn on my workpiece under visibility, and I could see. So it looks like I might have cut a little deep. That pocket must have been only 3/8. So I'll pick that pocket and add it. Other than that, all the rest of it looks pretty good. Yeah, we're going too deep on that pocket there. So we have to find out where we're at. So let me just take a quick measurement. We got that wall there, and that's going to be 3/8. And that wall there, which is 3/8, I believe. Yep. All right, so I just have an extra piece of geometry in that area. So for the 1/2-inch deep pockets, I'm going to reselect the geometry and remove that floor, and then recompute. And then for my 3/8 deep pockets, I'm going to reselect that and pick the floor. And that one should get it right because we've already machined it down to there. Hit OK. And then we'll go ahead and compute that. And now we have all of it. Only thing is, I guess those leads could work. They might not be the best, but we'll try them. And there it is. So we'll make sure to save that part file. And that's it. So when we get back after lunch, I have this one to kind of look at. This one's going to do some more face stuff, but we're also going to do some cross drills and some wrapping and a little bit of indexing. So overall, not too bad. So again, if you guys have any questions in the meantime, just go ahead and throw a question in here, and I'll answer it when I can. Thanks, everyone. We'll be back at 1 o'clock Eastern time, whatever time that is for you. It's an hour and 10 minutes away. So thanks, everyone. By picking a workpiece, it's always there. By not picking a workpiece, I can turn this CAD layer off and then actually use the CAD layer itself. I can turn it on and off if I want to see my solid model. So I'm not going to pick a workpiece. I'm just going to next pass that. And then right here, we're going to create our stock. Again, I'm going to go with cylindrical stock in my x-axis, and I'm going to tell it to calculate the stock. Now, if you want to be sure, go ahead and say bounding cylinder, calculate the stock. Shouldn't change anything there. All good. The only thing I am going to do is on the end face, going to go ahead and add, we'll do 3 inches again like before, just so we pull that part out of the stock. So from here, I'm just going to hit next. And right here we have our coordinate system. So for this one, you want to be careful. So if you look, this part wasn't perfectly centered on XYZ0, which could be a big deal, but it's not really that big of a deal for us. The big thing is, instead of just being able to use that origin point, I have to come in and pick that center point first. And the reason I have to do that is if I was to not pay attention to this, if I was to just look at this and assume it's in the middle there, and pick that as my X, and pick that as my Y, if that doesn't automatically give you the right direction, then usually what that means for me is that there's something off here. There's some sort of tilt to this. And it's tough to see, but maybe if I go to that view, there we go, a lot easier to see there. My coordinate system is not square to the front face. It's got that tilt to it because I'm pointing at the point up above, so it's on an angle. So I need to reset my coordinate system. All right, that puts it back. And then I need to make sure that it picks the front face, not XYZ0. I need this little 90 thou accounted for. Or I would need to add that into my face geometry. So again, the X direction, now that it's on that point, is going to go this way. My Y direction is going to go up this way. And if we go to that front view, we're square to the front face, no angles. And when I picked those two, it did get the right direction. It didn't reset anything. It didn't make me have to flip anything. For me, that's a big sign. If it doesn't get my X and Z in the right position right off those 2 picks that I just made, then for me, that's usually a sign that, that I'm not working off the front face properly. So I'm just going to go shift the part out in Z. So I'm going to pull this out of the stock or out of the chuck. We'll say 5 inches. Let's go, 5 inches should be good. Yeah, that should be plenty. And then I'll scroll down. And right here, I'm just going to hit OK. And so now we have our origin on there. And so we'll blank out the stock. Again, make sure you check the material there. And then I could go up to my tool crib, and we're just going to start adding tools in. So looking at this, I believe all the holes that I have before I set that up, let's take some measurements. I believe all the holes I have are a 1/2 inch. So even these OD ones, so we need a 1/2 inch drill for the front face, the center hole right there. We also need a 1/2 inch for the cross drills out here. We're going to need a turning tool. We're going to need a grooving tool for back here. And then that's really it. I don't know what the radius is here because it's on a curve around it's a curve around an arced surface. It's always going to read as a spline. So we have to make sure that the tool we pick can fit in there. I'll just stick with something, probably a 3/8 or 1/4 inch tool. These ones right on the front face here, we could take a measurement of that arc on the inside and find out what radius can fit in there. So again, read it as an arc, and it looks like if we use a 1/4 inch tool, we should be fine. So we use a 1/4 inch tool, that'll do the inside. It'll do this outside area as well. We need to set up some cross drills, and again, we'll use just a 1/4 inch 3/8. We'll figure it out when we do it. So back to the cam tree. I'm going to do my tool crib. And so I'll just do, what did I do before? Odd stations? I think odd stations, we'll find out. I'm going to add an adapter first, and I'm going to do a side mount, and I'll do a face milling adapter first, and just hit OK. And we'll set that to the side face, and that's not where I want to put it. I want to put that on station 2. So there we go. So I'll do my turning tools in the even number positions, and we'll say live tools on the, I guess I got to do them on station 1. Oh yeah, I only have one spot on here. So we'll side face that. There we go. And then we'll mount our turning tools into the other stations. So for that one, let's go ahead and add our tool. We'll say add tool. And I'm going to make this one my center drill. And I'm just going to keep it with the 1/4 inch center drill, just because I know that fits everywhere. Station 2, I'm going to go add in what I plan on roughing this part with, which is just a CNMG. Nothing too crazy. I'll probably use that for the rough and the finish. So I'll say add an adapter. We'll go with the side mounts, and I want a turning tool for the X adapter, and then hit OK. And again, set that on the, we'll leave that on the front face there. So it's going to be sticking out like that. Why do we not have side face mounting positions? I want it, or let me try this. Let me delete that one, and let's see what we got from our VDI. Let me try a turning tool X adapter here. There we go. That's a lot better. So that one's going to mount on the side face there, or on the, I guess, the front face. Sorry, the side face is the outer. And then if your turret has the ability, mine doesn't right now because this one's not set up for it, but you also have back face options, and that's going to all be defined usually when you submit the machine and the post to our posting department. They'll build all of that into it as well. So now we're just going to right click, add a tool, and this one's going to go down to lathe, and I'll go ahead and just pick my CNMG here with a 64th rad. If you want to open it up and look at it, you can. I'm just going to hit OK. And there's my tool. Now, anytime you work with turning tools, the big thing you want to do is make sure they're sticking out some. So this always confuses people the first couple times you're doing it. Remember, we're using a tool that's aligned with the x-axis. This red arrow here is also a little reminder that you're aligned with your red axis or with your x-axis. So I want this tool to stick out a little further. The direction that these arrows are pointing is the positive direction. So I just want to come in my X here, I'm going to say -3. And that's going to tell that tool to stick out. If you were to go with a +3, it's going to go the other way. So you're kind of losing the tool. So we'll just say -3. And there is the tool we'll use to kind of rough the majority of the shape. We got to do a little work for the geometry there, but no big deal. The next one we're going to pick is going to be the, we'll do the 1/4 inch. Let's just do the 1/2 inch drill. So we'll add a tool and an adapter. So we'll do our side mount, face milling. Okay. Make sure it's mounted to the side face, and then add our tool. This one will be our 1/2 inch drill. And so I'll sort by my diameter to scroll down until I find myself my 1/2 inch. And hit OK. And that one's sticking out the correct direction. So now we have our center drill in our drill for the 3 holes there. We then need a, we could do our cross drill next. Let's see, let's add an adapter. Let's do a cross mill adapter. So there's that one on the front face. Now for this one, I'll go ahead and add, excuse me, another center drill. So I'll add the tool. And then we'll go to our center drill. Again, I'll just pick another 1/4 inch center drill. Now, when we do a cross mill or use a drill, we have to pay attention to the orientation of the tool. Orientation 1 is for face milling. We want to go orientation 2 so that the tool sticks out sideways. It's a pretty short tool. I should be fine with that, though. So we'll shrink these up. We got 1, 2, 3, and 4 done. And then we need a face. All right, so we'll add our adapter, side mount, face milling. Okay. Again, set that to the side face. And then this one, I'll make a 1/4 inch flat end mill. So again, we'll add a tool. Go to the mill category, sort by the diameter, and find us our 1/4 inch flat end mill. I'll go ahead and use the long one just because. And there it is. It's already in the right orientation. So now we have the tools that'll do the front face. We're going to turn this to size. We'll clean up around that, that hex there. We'll be able to do the inside pocket. We'll be able to drill the holes, and that chamfer will be made when we turn it. So really all we have left is we have the center drill for the OD. We need the drill for the OD, and we need some tools for the OD cuts. So first things first, let's go ahead and put the drills in. And we do have one more turning tool that we need. It's going to be a grooving tool. So where do we have that turning tool now? It's in station 2. So I should be able to put this, let's go ahead and put this in station 6 here. And I'll go ahead and just add an adapter. And this one I'm going to use the VDI adapter, and it's going to be the turning tool X. Hit OK. Make sure it's mounted to the front face. In this case, it's the only one I got. and then I'll go ahead and add a tool. Now, the big thing I need here, and I don't know the exact depth of it, but I do need to make sure that when I choose my grooving tool, I have enough of a tool kind of sticking out. So I'm always going to double click this and then scroll down to the holder here. Now, if I say edit a tool holder, I could find out the distance that that's sticking out. So if we click in this picture, it'll tell us what that distance is. So I have 1 inch of stick out right now. I'm okay with that. It might be shorter. You could change the length of it, whatever you got to do. I'm just going to hit OK and add that one in, and then hit OK once again, and there is my tool. So same thing as before. We need to, we need to make sure that we add the distance down. So I'm just going to use the same value, -3, and the tool is going to be sticking out just like that. Now, if you ever need to flip the tool because the insert's on the other side, that's what this button right here does. Lets you flip that. You also could switch the orientation of it altogether. But we're going to go with orientation 1. Let me make sure this looks good. Let me move this. There we go. There's our insert right there. So that looks fine. All right, now we have our center drill. We just need our drill. So let's go ahead and add in, we'll say add an adapter. We'll do a side mount. We'll do a cross mill and hit OK. Let me zoom in on that, kind of rotate it around. Looks good. It doesn't zoom to cursor here. So to move this around, if you hold Control down on your keyboard and you left click, you can move that so you can line up your view a little bit better, get a good view of what you're seeing. And we'll add a tool. We have our center drill. We just need our drill. So 1/2 inch drill. Oops, that's not the one I want. And we'll go down, pick another 1/2 inch drill, hit OK. And then make sure it's on orientation number 2. And then we have our groove tool, we have our center drill, our drill. So let's go ahead and add in our 1/4 inch end mill. So we'll put that on station 9, add the adapter. Again, this is going to be a side mount, cross mill, OK. Make sure it's on the side face. And finally, add a tool. Now, that's a majority of the tools. I think I have everything. We have some open places just in case we have to come back in and pick anything else. We can. We just need to make sure that looks good so far. So I think I have all of the features covered for tool wise. I think I have all the tools covered. But again, if we need to add anything, we can. You can add tools to the system as you go through your features as well. It's just not the way that I would recommend doing it. I recommend setting up your tools and then adding the features kind of afterwards. If you were to, if you go in and add tools, it could mess up the numbering. You just got to make sure everything's set up the right way. That's really all it comes down to. So when we're done, we can hit OK, and that's going to save that tool crib. And just like before, after I set up my tool crib, get my stock set up, I'm going to go save because I do not want to have to set that tool crib up again, especially since I'll probably forget something anyway. So the next thing we need to do is get the geometry that's needed to turn the basic shape of this part. And we do that by using a feature under Create 2D called Spun Profile. It's a really easy feature to use. All you really need to know is what axis is running down the middle of your part. Now, that's the axis of the CAD window, not the axis we created, because the one we created would say this is a Z-axis spin we need, but on the CAD window, it's an X-axis. So just be aware that really any CAD features you work with in BobCAD, or every CAD feature, is always going to work based on your UCS XYZ origin. Even if you change to a front or a side, it's still going to use that point for all of its drawing. So I'm just going to add a layer here, and I'm going to call it Spun Profile, and make sure the check mark's on it. And then again, under Create 2D, we can go to Spun Profile. And the way this is working is we're taking this part and spinning it, and then generating the wireframe off of it. Now, that's important because this hex here, if we were to machine it to the middle of this surface, we'd be cutting our part too small. So we want to make sure that the spun profile, which it'll do automatically, calculates based off the points, kind of the widest diameter we have. So I'm just going to say along the x-axis, drag a box, hit OK, and then wait for it to turn back to its normal color, then cancel out, and we could turn off our CAD layer. And that's what we're left with. So now what I want to do is I want to go in. I always like to make sure or try to rebuild the geometry if possible. Sometimes it works, sometimes it doesn't, especially these little breaks here. What's happening is it's breaking the geometry based on kind of the ends of these entities here. So we're getting a break there, we're getting a break there, we're getting a break off the edge of the hole. So that's where it's calculating it all from. To fix it though, I'm going to try just going to utilities, clean up, optimize, and I'll drag a box over the whole thing and then hit OK. And so it made a bunch of corrections, 32 of them. And so we could see, we could look at this. It's still got some breaks in the geometry, but not as many. We had a lot of smaller breaks. It's up to you if you want to work with that. I do like to, I do sometimes just redraw some of these things. So like I'd go in and pick all of the entities here, all the way down, and delete them. Same thing with this one right here. Just pick it and delete it. Make sure there's no little overhangs on it. That one's a single piece. That's a single piece. That I don't really care about. That one's broken, but I don't really need it for anything. And this bottom one's broken, which, again, don't really need it for anything, but I'll go ahead and just get rid of it and redraw it. And then, yeah, that's got a tiny little entity on the end of it there we got to make sure to get rid of. Otherwise, we'll have little duplicate overlaps. So there it is. Anything else that's broken, usually the breaks are going to happen along the x-axis, parallel to your x-axis of your CAD window or your z-axis of the job. Now, in version 34, they added in, if you guys are still using 33 and struggle with snapping points, they added in the join to closest snap point option. It is fantastic for sketching in lines. I can go and just click on a line now. Oh, whoops, got some weird, let me turn off these points here and here. There we go. So I'm just going to join this up, click the points. You'll see it'll actually snap to the snap points, even if I'm not clicking on a snap point. As long as that button there is clicked, it'll join to the closest snap points. So otherwise, if you're using version 33, just try to make sure the point turns red when you click on it. Otherwise, sometimes you'll be missing your geometry. That's even more noticeable when you have geometry that's not perfectly flat on an axis. Sometimes it'll give you some weird stuff. So that looks good. Now to double check the geometry, kind of make sure everything's all good, just grab your select tool, hold shift, and click. And you'll see I just went around to right here. And what you'll see is I have a tiny little entity right there. And I should have known that was going to be there because there was one on the other side. So the way I'm going to pick it is I'm going to pick that line first. I'm going to pick my long line here second. And then I'm going to drag a box over it. And that box has to touch the two lines that I've already selected. This is going to deselect those two lines. And it's just going to select that little one there. So I'll delete it. Again, to double check it, grab select tool, hold shift, click, make sure the chain goes all the way around, then check it from another spot. So I'm clicking it, still holding shift down, I'm clicking it again to turn it off, and I'm going to go to a different line and click that. The reason I check two sides is because when you send a chain in BobCAD, when you hold shift and click on something, it actually sends the chain in one direction. If you really want to understand that, the best way for me to put it is it's all based on the midpoint. So if the middle of the line is here, if I move to the right, hold shift and click, I'm actually sending the chain to the left. We always send the chain in the direction that's the longer side of our click. So when we hold shift and click on something, if you're right in the middle, there's real you won't really know which way to go. So don't click right in the middle. Click at like the 3/4 point, 3/4 of the way down this way or 3/4 of the way down this way. Whichever side is the long side is the direction that we're going to send the chain. Excuse me. So if I hold shift and I click the right side of this line, it's going to send the chain to the left. And if I hold shift and I click it click on the left side, it's going to send the chain to the right. Now, I've done this enough times that sometimes you get lucky. And when you hold shift and click, the whole thing lights up and you think, all right, great, everything's good to go. I'm ready to run with this thing. But what ends up being the case is because I held shift and clicked this way and the chain went around the part, it naturally stops at this line. Well, guess what? If there's a problem with that line, with that corner right there, then you'd never know it. So you hold shift, you click, it lights up. Even if this was overhanging this, it would still light up because it ends right there. And a lot of times the problem geometry is it's not going to be some long line. It's going to be a little tiny piece of geometry. So by holding shift and clicking it and doing it in multiple places, you're ensuring that lucky chain gets found. Because like I said, it doesn't happen often, but after it happens to you once, it's annoying enough that you never want to deal with it again. So there we go. We may need to, when we do our turning part here, we may need to separate this geometry onto its own layer. Now, we shouldn't have to do that anymore. We do have some features in the turning to avoid grooves in the part. They're undercuts. But it might read this as a groove if I try and run that option. We're going to find out. We're going to go to the CAM tree here. And right here, I'm just going to right click on Machine Setup 1. I'm going to go down to, Machine Setup 1, go down to Lathe or Turn Features, and I'm just going to do a lathe turning. I didn't leave any material to face off, or normally that would be my first step. So I'll go ahead and select my geometry. And so the way I'm going to pick this geometry is right down here. It's a slight curve on this. So I'm just going to click on the beginning of the first entity right there, all the way back. I'll go to this last entity all the way back here. The reason I'm going back that far, including this groove, is because right now I'm going to see if it works. If not, might have to change some geometry. No big deal. We'll go ahead and hit OK. Next, we get to our feature tab. So we could define our feature type. So this is an OD cut. We're going region 1, which basically means we're starting from the front face, working back towards the spindle. The undercut section is here is how you would remove the grooves that are in your part. So you have a remove primary undercut, which is going to remove any turn grooves from the geometry. We also have a remove secondary undercut, which will remove any face grooves from the geometry. If they're both turned on, we're going to ignore all turn grooves and face grooves. This button right here might be the reason I don't get toolpath here or here, because it's avoiding grooves and it might read them as grooves. So we'll find out here in a minute. For the constraints, for the first toolpath, I always go from stock, because from stock is going to look at where the stock is, where the geometry is, and it's going to go and just remove the material accordingly. When we get into grooving, I usually use something like from geometry so it knows where the top of the groove is when we're making the cut. For extensions, this will let me start in front of the part a little bit. So I'll say start an 1/8 inch in front. And then for my end groove, I'm just going to go an 1/8 inch past. So just to clean up a little bit more without having to worry about leads. Next, we have our machining strategy. So for this one, I do want to do a rough and a finish. I'm going to use the same tool for both, but I have a rough and a finish. For posting, again, separate moves or CAN cycles. That's all going to depend on your post processor. For the roughing tool, it's got my CNMG. It's the tool number 2 there. So just verify, hit OK, and then next. Now for the patterns, I'm going to keep it pretty standard with this one by using the standard pattern and the standard sort. But really, a lot of these features, as I go through them, I'm only going to make changes if I know I need to make changes. So depth of cuts, step overs, tools and stuff like that. Other than that, I'm going to try and keep most of these settings on the default. Now for turning, right here for compensation is important. If you're making a tool or you're using a tool that is a real tool, meaning the tool that we just defined, it's a CNMG, it matches pretty closely to what's actually going to be in the machine. Well, I want BobCAD to check with that holder and that, with that part to make sure we're not colliding anywhere. If we didn't turn this on, this, this CNMG would come in and it would actually try and cut this area as well, and it would gouge the whole way around. But by turning on with collision detection and use the tool holder, we're going to shift and avoid cutting anything that the tool is going to hit on. So we'll give it a shot. For the parameters, depth of cut, I'll just go 50 thou. So that's per pass, we're going to take off 50 thou. For my finish allowance, I'm leaving 10 thousandths for the finish tool to clean up. And for my overlap, I'm going to go to the previous cut. So what that means is normal overlap with no overlap would mean we make a cut and we leave. To previous cut means we make our cut, and instead of leaving there, we're going to follow it up and leave right there. So you're kind of doing a semi-finish on your part. You're not going to have a bunch of abrupt, jagged geometry here. Compared to that, if you were just doing like a no overlap where it just runs in and leaves, you'd leave the radius of your tool every time. So this will just give you a better blend before your finish tool comes in. We do have a chip break option, which allows me to base everything off the length of the cut, the amount of time, or the length of the chip, and it'll just retract the tool to try and break the chip so you don't build up a big rat's nest on your part as you're working. Corner types, we've got round or sharp, and this is the interpolation of the tool. So it's just kind of how the tool is going to roll a corner. Notice, even if we leave it on round, we're not asking for any sort of radius here. If it was there to leave a fillet or a radius on the part, it would always ask what the radius is. You'll see little features like this inside of some of the milling tool paths as well, like the corner types. There's a round option. Then it's just to change the interpolation of that. So instead of having in the code 2 line moves, you're going to have a line, an arc, and then a line. You'll get the same results though. And then finally we have trim to stock, and this one really is I use this for when I do casted parts. A lot of times I'll have the final known shape and then I'll have a casting that's oversized. What we could do is we could make 2 models, one that represents the casting and one that represents the final part. And by using this feature here, you can get it to avoid cutting in the areas where there is no stock. So normal cuts would look like this. We're wasting all this time cutting a bunch of air, where if I was to go in and set my stock, set my stock up properly, it'll trim to where it actually sees the stock. Great option, but a lot of it entails you having more information, usually another piece of stock. So next we have our rapids. We got the default rapid on the approach, default rapid on the exit. I'm going to leave those defaults. For the leads, I'm going to leave the defaults. I try to leave the defaults on the leads every time, and if they cause me a problem, I'll come change them. But most of the time, these are usually not the cause to the problems I run into. For the advanced feeds, it's just your convert rapids to feed, and then the feed rate percentage used when doing a lead in and a lead out. Then we have our MDI. Right here we have our basic finish. So now you'll notice the tool shows up as -1. If the tool shows up as -1, the tool that it's looking at doesn't exist. So I'm going to go to the tool crib, and I'm going to go to the lathe rough, and I'm going to choose tool number 2 and just hit OK. That tool exists. That's why it has a proper tool number. Next, again, we have our patterns. So I'm just going to do a continuous finish. We're going to go from the start face just back. You could also do any vertical facing. You could back drag, and any turn diameters you could do separate. So I'm going to go with continuous. Again, on with collision detection using the tool holder. That is a setting I have on every time I do it. So if I wanted to save my defaults with that setting, it wouldn't be a bad thing to do. But then, people might wonder why mine's always on, and I'd forget. So next. Right here for the parameters, this is a finish pass. So we're going to leave that at 0. Other than that, just chip break, the rest of the stuff, rapids, got our leads, got our advanced feeds, and finally the MDI. When we're done, we'll hit compute, and we're going to wait until we see the results. And there it is. Not too bad. It did the front. I didn't want it to do the back, and kind of the way I set this up, the stock fits the part perfectly. So it doesn't see any stock to machine here, so it's not going to do it. The groove right here is what we then need to program. So again, we'll go back to our top view. And I'm just going to blank this out and shrink it up. And then for the groove, we're going to right click on Machine Setup 1, go down to Turn Features, and then say Lathe Groove. We'll then select our geometry, and all we're picking is the walls and the floor to the groove. Hit OK, go next. Right here for the feature page. This one, I'm going to say from geometry, so it looks at just the top, but at this point with the geometry or the stock being right there, it would give us the same thing. So from geometry, from stock, it's the same results on this one. No extensions on there. Give me 1 second. All right, so for the groove, we're going to go with a groove rough / finish, which is going to give us the groove, the rougher, and the finisher. Next, we have our posting page. Again, separate moves or can cycles. Next, again, we have our groove. So I'm going to go up to the tool crib, make sure it picks. It should be tool number 6 there, 1/8 inch wide, hit OK. Looks good. Patterns. For this one, I'm going to, again, keep it on pretty standard, but if you were using a grooving tool that has a specific shape groove in it, you could do a single pass, or you could come in and do zigzags, but it's not something I've done too often, usually specialty tooling. So I'm going to go with a zigzag and then, a standard with just a standard sort. And just like in the other turning tool path, we had the collision checking. We need to make sure to turn on use tool holder. This is super helpful if I accidentally picked a tool where the length of the tool sticking out, the grooving part of it, isn't long enough. This is going to adjust the tool path so that I never touch my holder to the part. And if that's the case, you'll see it. It'll have a big angle in it. I picked one that's got a 1 inch long stick out on it, so it should be fine. I never measured that. I don't know how deep it is. I don't think it's over 1 inch though. Right here we have our step over. I'm using an 1/8 inch wide cutter, an 1/8 inch wide grooving tool. So I'm just going to set this to 60 thou. Finish allowance is how much I'm leaving for the finish groove to clean up. And if it was a real deep groove, you could do it in multiple depths as well as peck that thing out. Other than that, we're just going to process by area, meaning we're going to finish an area before moving on to any other ones. You also have the choice of going by level, so you're bringing all the areas of the part down at the same level. I only have 1 groove, so that doesn't really matter. And then, again, you got that trim to stock. So next, right here for the rapids, going to use the defaults. For the leads, going to use the defaults. It's the only option we have. The advanced feeds, no changes. MDI, no changes. And the groove finish. It's tool number 6. I'm going to trust that it got the right one and just go next. For the patterns, once again, on with, collision detection, use the tool holder. Now the 2 patterns we have is force down cutting. So we're going to go from both sides of the groove and meet in the middle. You can add an overlap if you'd like. We could also go with the basic finish here. So I'll just turn on the basic finish, just 1 pass across the groove. Parameters, just finish pass, so leaving 0 for the allowance. Rapids, going to use the defaults. Leads, I'll try the defaults. Advanced feeds, defaults, and MDI, defaults. Again, I'm trying to make as little changes as possible because a lot of the settings that are in here as default will work. You're just going to go in and make the changes as they come up. As you see a tool path have a problem, you're going to go and make a change. For those of you that were here before lunch, I messed up quite a few things on that tool path, but I was able to see them inside the simulation. I was able to figure out which tool path was causing me the problems, go back, make a quick change, and then that was it. You'll also notice, and I pulled this up earlier on this cheat sheet deal here. I didn't go through the whole thing, but down at the bottom, or down in step number 4 here, they say simulate to confirm your results. Well, if you were to simulate every tool path every time, you're going to waste quite a bit of time. I'm not against it. Feel free to do that if you want to. What I do, though, is I get down to the bottom, step number 8 here, and I simulate the final program. That way I could just focus on doing all my tool pathing without waiting for my simulation to load and compute and all that stuff. So just a heads up, there is a step in that little cheat sheet about simulating, while you're making your tool paths. I don't want you guys to think I don't do that. I do that once in a while, but usually I just wait till it's all done. So I'll hit compute, give it a second. And then give it a save. So we'll go ahead and save that guy. And then I'll blank it out and shrink it up. So I'm not even worried about, really what it looks like. Looking at the tool path right now, I mean, it looks good. I got no problems with it so far. So I'll leave it there. And then that's about it. Now, when we go to do the hold down the center, if you're using a live tool, you want to use the mill features to do it. If you're using a turn feature, then we can go in to turn features and just do a lathe hole. The lathe hole is a little easier just because you're not really defining much about it. You just hit OK, go next. You just have to make sure to fill this out. You're just really picking the depth for it. So we'll go next. Going to choose the lathe hole, which gives me the center drill and the drill. Next. Got my 1/4 inch 90-degree spot. Don't know why it's picking the wrong tool. Let's go to the tool crib and make sure to pick the right one. So we need to make sure we're picking the face milling one. So we have 2 of them here. It's on our face milling adapter. I think the problem with it is the depth that we're set to, but we're only going to go, 160 thou deep. That's fine. Well, actually, let's go 200 thousandths deep, or the center diameter at 200 thousandths. There we go. Not sure why I didn't pick the right tool there, but all right. And then for the drill, once again, I'm going to pick our drill as the face milling drill and hit OK. I think it could be the depth that we're going. What's the depth on the hole? 4.6. And the stick out on our drill is 4.75. So it's close. We don't have to drill that deep either. Because technically, I mean, we really could clear through back there and then clean up the rest from the other side. But however we want to do that, I'll go ahead and peck my way out of that one. Oh, there it is right there. So the overall depth is at 4.8. So I'm going to set the overall depth to, I'm just going to say 4.6. I don't care if it doesn't break all the way through. I can clean up the other side later on. So next, and compute. And there's our drill down the middle. Now, if you want to look at it, you can go ahead and say back plot and just kind of next your way through or turn your speed up and just hit play and see where it stops. And also, if I go to a top view here, I can see if I'm going to collide with the part at all. Looks like I left it a bit short, so that's good. So again, we'll blank that out and shrink it up. Give it a save. All right, so that is all the turning on this part. Yeah, that should be all of it. So now we're going to go in and start doing all these extra cuts. It's all about how whatever order you want to do this in. But remember, you can either leave your geometry or your tool path sorted with the machining order as individual tool, or in the order you want it to run in on your CAM tree. So I'm going to go just up to the machining order now, and I'm going to set it to individual feature and hit OK. I want it to go in the order that I have my CAM tree set up. So the next thing I'm going to do is let's go ahead and pocket out this little star here. We can use the open pocketing feature. So that just means we're going to use the, we're going to use the, I forget the name of it, advanced pocket. Sorry, that's what I'm trying to think of. And if you've done this in the past, you can absolutely copy and paste tool paths. I could go back to the one we made before lunch and copy one of those pockets. I'm not going to do that because it's cheating. But absolutely, if you've made a tool path before, you can use that tool path over and over again. If it's a certain feature you're going to use all the time, you can actually save them and reload them at a later point as well. So I'm just going to right click on machine setup 1 here, go down to mill features and mill 2 axis. For the geometry here, I'm going to select this floor, and I'm going to leave that option on that says detect open edges. All right. And that should give us a cut that goes over this hole. If not, the geometry technically is just that edge there, if that's all we wanted to pick. So I'll go with my chains. That's all fine. The only thing I would change potentially is my start point. I'll put that right there so it's got a bigger area to kind of open up into, to plunge into. And if I knew the distance between here and here, I don't know what it is, but we'll call it 1 inch. If that was 1 inch across, I could do like a right angle lead that plunges right down the center of the hole and feeds to the wall. The only thing I'd need to know is the diameter of that there, and then what tool I plan on using. So I just do some basic math and figure it all out. The other thing we're doing is we got to pick the bottom, which is right down there. It is at 1.102 deep. And so we'll just hit OK. And next. Right here for the feature, no changes. Just going to go next. Right here for the strategy, we're going to choose pocketing. And again, if you're doing spring passes like we did on the last one, don't add them here. Because then you have to go through and define those extra spring passes as you go through it. What I do is finish one profile finish and then copy and paste and calculate the other extra however many you want. We're not going to do any spring passes on this one, though. We'll just mess around with this. So next, no changes there. We'll go next again. For the posting, no real changes there. Next again. Multi-axis. Actually, for posting, I'm going to turn on longhand now so I remember that. Next again, we have our multi-axis posting. And finally, we get to the tool we want to use. So I'm going to go up to the tool crib. In my end mill rough, I have a 1/4 inch flat end mill, and the adapter is the face, so that's the one I want to grab. We'll go next. For the pocket, we'll do a advanced pocket, and then I'm going to use a morph spiral on this one. We'll set our step over to 20% and go next. Side allowance, I'll leave 15, so this tool is going to come back in and clean up 15 down next time. For the steps, I'm going to break this down into, we'll do it in 6 steps just to keep it kind of light. So 1.1021 divided by however many passes you want to go. So 6, and it'll automatically break it down for us. Next, we have our leads. We can go ahead and I'll plunge in with this one because I did drill a 1/2 inch hole down the center already. Sequencing, it's only one pocket. It doesn't really matter. I'll go optimized. Links, no changes. Advanced feeds, no changes. MDI, no changes. And now we get to our finish pass. So again, we're going to go to our tool crib. We're going to pick the same tool from the end mill rough category. So just make sure you got the adapter right. And then hit OK. Right here we have our pattern. So again, I always like to have that G41 on there just in case I need to make a change out at the machine. But remember, the G41 will only output in the code if there's a lead-in move to it. So on the leads page, we can't use a vertical lead-in. It's during that lead-in move that your machine's actually going to apply that compensation. So you have to have it. Otherwise, we won't even output the G41 or the G40 anyway. So next, right here, we have our parameters. Again, I'm just going to finish the whole thing. I should have enough flute on there because I picked my long version of this tool. So I'm just going to machine the whole thing. I'm only shaving off 15 thousandths. For the leads, I'll do a right angle, and I'm just going to set this to half the tool, so 0.125. All the rest of the material inside the pocket should be gone, but I am going to give it an overlap here. I'm using a 1/4 inch tool, so I'm going to overlap it by 1/8 of an inch as well. So as I lead in, it's going to lead in here. It's going to cut its way around, and then instead of leading right back out, I'm going to go past it and then lead out. I may have to move my start point, but we'll find out. So I'll go ahead and hit next. Right there's my corner types, no changes. Machine sequencing, no changes. Advanced feed rates, no changes. And finally, the MDI, and no real changes. So I'll hit compute. And there it is. Looks pretty good. Let's go ahead and blank it out so we can see them. There's our pocket, and there is our profile finish. So there's that little overlap between the two. And so I'll shrink that up, and there we go. Now for this area here, we have a, well, it's basically an arc. And so I want to just switch this to a side view right there, just like that. And then what I'm going to go and do is I'm going to extract the edge off of this face here. And what that's going to do is it's going to let me find out basically the diameter of this whole thing. Because right now we have our CAD is turned down to that level right there. So I don't need to do a full open pocket that goes and removes any of the material basically from here to here. I just need to clean up that one. So I'm going to go to Create 2D and Extract Edges. I'm going to project to my Z plane of 0, so it's going to flatten it out for me. And then I can go and pick that surface there and hit OK. Now, if I go and just hide, whoops, hold on, let me hit undo. Let's do this a better way. Let's do our, this is our hex geo is what I'm going to call that. And yeah, try that again. Make sure we put it on a separate layer so that it doesn't interfere with, say, the spun profile or anything, or the CAD. So there we have it. I can then get rid of that star shape in the middle. And then there we have our arc. So I'm just going to go and draw a line. This is a quick way of getting a measurement between 2 points. Just draw a line and then go to your Evaluate tab and do a measure 1. And down at the bottom, it'll tell you what the total length of that line is. That's the length that we need. So what I'm going to do is I'm going to make an arc that is, we'll say 3.5 in diameter, maybe we'll go 3.6. So just create 2D, arc, and then a diameter. I'm in version 34 here. So for those of you that have version 33 or previous, version 34, they added the diameter button to your CAD features. So you can enter the diameter or the radius. I'm going to enter the diameter at 3.6. It's a little bit bigger. And before I finish that, I'm going to go to the bottom corner of the screen here, down here, and I'm going to change to a dotted line style so that when I hit OK, that line gets created as a dotted line automatically. Now I could just use my select tool and get rid of that construction line I made a minute ago just to get it out of the way. So now I'm going to tell it to use this as an open pocket. I'm just going to let it work its way around there. And we got a little bit of meat still, right here, but not so much right there. Again, we're going to do actually the same pocketing routine. And this is a big reason why I like using the advanced pocket all the time. If the geometry is closed, it's going to treat it like a normal pocket. If the geometry is not closed, though, or it's an open pocket, it'll still work. So let's rename this the star pocket. Whoops. Oh, that's a note. Cancel that. Let me rename that and call it star pocket. And then I'm going to copy the star pocket, and I'm going to go ahead and paste it. And do you wish to use the same top and depth? Sure. Doesn't really matter. I'm going to rename this X open pocket. And now for the geometry, I'm just going to pick, holding shift, I'm just going to pick the hexagon that I pulled off there and the arc right there. So the both of them. And if we turn our CAD model on, I'm going to go back to my top view. We can now make sure that we have our top apart at 0. That's great. The total depth is going down to right here. So I'm going to pick that point there, which it's the same depth. So this should actually be broken down into my about 3/16 passes. So the only change I want to make now is I'm going to do my leads for my inner chain there. I want them in the middle. So I want them in the middle along my X if I can help it, right over there. We could also go right on that. Let's go on that corner. We'll set them on that corner. Actually, no, we'll go right there because I have right angle leads currently. So we'll try that. So hit OK. And then I'm going to right click on that pocket and compute all toolpath. And give it a second. Go ahead and blank it out and we can see individually. Let me turn off everything but the solid here. Get out of here. There is our pocket around the outside, kind of taking care of anything extra. And then we have our profile finish. Now the profile finish, I wasn't paying attention when I picked my chain. The start point is going the wrong way. That's why we could see it inside the part. So I'm just going to right click on the default chain start point here and say modify. And then that lets me I can just click on the tip of the arrow and flip the direction. Or I could click over here in my profile chains, figure out which chain it is, and then do this little button here to reverse the direction. So again, we'll hit OK, and then I'll just recompute the whole thing. And now we'll see it on the outside. So that looks good. All right, we'll shrink that one up. And we're now going to do just the drilled holes on the front face there. So I'll do my mill features, mill drill hole, select the geometry, and just pick the surfaces on the inside. The best thing about that is it's not only reading the diameter, it knows the center point, it also reads the depth right in there. So it knows how deep to drill. So I'll hit OK. It's not a through hole as far as I don't believe it's a through hole. So I'll leave it blind. It is a 1/2 inch diameter, and it picked the bottom based off of the depth. So the top of features there, the total depth is there. Now with the top of feature being so low here, it's going to run through the part. And I'll show you how to fix that in a minute. We only have 2 holes, so I'm really not too worried about it. But we'll go hole. We got our center drill and our drill. Next again. Right here we have our machine sequencing. We'll go optimized. Next again. No changes for the posting other than longhand code. Multi-axis posting, no changes. Center drill, going to go up here and make sure I pick the correct center drill, the face mill center drill there. Next again, for the parameters, we have our depth. I'm really not too worried about it. So next. We got our 1/2 inch drill, all good. Total depth, that's great. And I'm just going to hit compute. So right now what's happening is it's giving us a center drill. And if we didn't leave it like this, if we were to go in, a real easy fix to this is having your top of feature at 0. The problem is if at this point we set our top of feature to 0, our center drill is going to center drill air, and then our drill's not going to have any center drill to run into. So I'm just going to change the rapid plane to a height larger than the negative top of feature. Now, normally your clearance plane that you set up when you do the whole job should be the highest point. I want to go in and make the rapid plane the high point. And it's just for this toolpath. So I'm just going to say 1.3. So just 1.3 for the rapid plane, and then hit compute. And that's going to ensure that the center drill still goes down to its depth. Let me blank this out. So the center drill is still going to go down to its depth, but it's now high enough to retract over this area here. It's not going to hurt anything if your clearance plane is higher or lower than your rapid plane, but usually in most practices, your clearance plane would be the highest point that you'd go. But we have a lot to clear out over that, so it works out. All right, so that gives us, let's just unblank everything real quick and take a look. So that gives us the turn, so we'll be turned. We got the groove in the back, the hex pocket, the hole, all the holes. Pretty much the front face of this thing's done. So now we could start focusing on this stuff here. So for this one, I'm just going to go ahead and blank all that stuff back out. And I'm going to drill these 2 holes here and here. First. So I'm going to right click on my machine setup, and I'm going to go down to mill features and mill drill hole. When I select my geometry, before I go pick anything, this is not a standard drill. This is a cross drill. All right, so we're going to switch this to a cross drill. The rotation axis is our Z axis, and then we're going to go ahead and just pick the inside surface to both of those holes there. And then hit OK. Again, make sure you turn off the through hole. Next again. And then really the important thing for this one is it knows the diameter of your stock. So it knows that the clearance or the kind of top of the part is 2.5, and it's just going a 1/2 inch deep. So next our way through, get to the hole feature, which gives us the center drill and drill, which we did set up, so we should be good. Just going to next my way through here until I get to the center drill. Go to the tool crib and make sure we pick the one that's made with the cross mill adapter. Next again. I'm fine with the depth there, that's fine. And then finally the 1/2-inch drill. Make sure this one is using the cross mill adapter drill. Okay. And then finally we account for the depth in the tool. And so we'll hit compute, and there is our drill. That one's pretty easy. Now this other one, this middle one could be drilled with this one, but these other two are not cross drills. They're not pointing towards the center like directly. If with any of these holes that we're drilling now, this top one and this bottom, if we were to go all the way through, we would hit the center line. These ones are all just straight down, so they're normal to kind of there. So it's actually 3 holes. So for us to do that one, we want to do an index system first. So I want the part to orient to the center of this and then kind of drill all 3 holes. Now this is a perfect part that I made it this way. So it's kind of a perfect world scenario where I have a surface in the bottom of those holes that's flat. And that's what we need if we're going to define an index system. So to do an index system, you just right click on Machine Setup 1. You'll go down to Additional Functions. And right here we have kind of our modifications that we can make. So we have the index, we have the wrapping group, which we'll see here in a minute as well. And then we have our toolpath patterns. So I'm just going to say add index, and then the surface I'm going to pick is the floor of that part right there. And when we pick our index, I'm just going to hit the letter T on the keyboard real quick. When we pick our index, you'll see that it has it. I guess we can, yeah, there we go. The arrow should always be pointing away from the part. We always want it pointing away from the surface. So then I'll go ahead and hit OK. And the index is set. Letter T again is how you turn your part transparent, just T on the keyboard. And then using the index system, I'm going to right click and do my mill drill hole. So from here, I'll select the geometry again, just the center walls there. And we're doing this one as a standard drill. Hit OK. It's got multiple depths. That's fine. It's because it's reading the top and the bottom there. We are going to do it as a blind hole. And what you'll see is we have the top of feature ones, the center one's at 1 inch deep. The other ones are at 0.9645, and they're just going 1 inch deep. So again, we'll do a hole. And with this hole feature, I'm going to make sure to say apply to all features. And then go next. Right here, we have our sequencing. We'll go optimized. Next, again, we have our posting. Next, again, we have our multi-axis posting. Our center drill. So we'll go to our tool crib and make sure we pick the right cross mill center drill. Parameters, that's fine. And then we have our drill here. Again, it keeps grabbing the face milling one, so we got to pick the cross drill. And finally, the parameters. Now, if you look at this, we have our 2 different depths, group 1 and group 2. So that looks fine. We'll leave it right there and just hit compute. And there is our other drill. Beauty. So that's really all we need for the index system on that one. And really the last bit that we have to do is going to be this big pocket that we have here. There's actually 2 of them opposite of each other. So for us to do that outside pocket there, we're going to have to build a wrapping group. We're going to have to create a wrapping group. And it sounds worse than it is, but you do have to be careful. If you were doing this, if this wasn't here, maybe you were doing a pocket inside of it, it could change the wrapping group a little bit. But basically, we're just going to tell it to use the diameter. So right here, we'll go additional functions, add a wrapping group. And there's a couple little settings in here. First things first, I'm going to say use the stock diameter, which for us is 5 inches. It works out great. The geometry that we're about to pick, we did not unwrap this geometry first. So we're going to leave it as wrap geometry. If you were to go to Create 2D, there's an unwrap feature which lays the geometry out flat. And when you're doing some, I use it a lot that way when I'm doing, a lot of times it's pool cues and stuff. If I'm doing a pool cue and it's got inlays in it, we'll lay it out flat because you could do, you know, a little bit more. It's easier to draw some complex geometry that way than it is to actually have it wrap around a cylinder. So you can actually have your geometry drawn out flat. The tip I'd give you for that one is make sure the geometry is drawn out at the height that you need to machine it at, or the angle that the part is sitting on it. Like, think of a pool cue's got a taper to it. If I want to wrap something around a taper, the geometry that I'm actually selecting is going to match the angle that the taper sits at. And yeah, so that's it. I mean, there's more to it. If you guys want to get into 4-axis wrapping, we can do a day specifically for that. I usually do that I usually cover that a bit more when we do our 4-axis days. But all the steps that are in the 4-axis stuff are the same. So if you are getting into a little bit more wrapping, go check out some of the previous live events for 4-axis, and yeah, you'll be able to see some stuff. So the geometry we're using is wrapped. We're going to use the pocket floor right there, and then we want to show the tool path is wrapped. I want to see it on the part. I want to see if it looks good. So that's really it. We're going to hit OK. And so just like the index system, you know, normally with an index, or normally when we add a tool path, we right-click on Machine Setup 1, and that's where we add our path from. If we do an index system, that kind of takes the place of the machine setup. So we're going to go in and right-click on the index system to add our tool paths. Same thing happens with the wrapping group. I'm going to right-click here and go do a mill 2-axis. Or I could copy and paste a tool path into here. So I'm going to select my geometry. We haven't done any 1/4-inch drilling yet. This pocket is a 1/2 inch deep, so it's not reading any depths on here. It is it's a 1/2 inch deep pocket. So I don't need to pick the floor. I was just pointing that out to you guys. It didn't read any. It didn't figure that out for me. So once again, just going to pick the other side as well. And right there, come on, right there. There's a break in the surface, so I got to make sure to pick this. A lot of times, if there's no break in the floor of your surface, you can just pick that whole floor. But for whatever reason, when I was playing with this one earlier, that break in the floor made it so that I only got tool path on one side of it. So I don't do that. I'm not doing that this time. And so there it is. We got our 2 chains. You know, I'm going to put my start point for the chains in the middles and in the middles right there. And then to the left should put us on the inside. So that's going to be our finish pass. And yeah, top of features at 2.5. It's going from the center of the part to the outside. So it's a 2.5 inch to the outside. And then I'm going a 1/2 inch deep back in. So we'll hit OK. And then go next. Feature page, no changes there. We've pretty much set all this stuff up when we did the selection in the clearance plane. For the machining strategy, we'll go with pocketing. It's going to give us a pocket with that profile finish. Next again. And honestly, the star pocket, the hex pocket, the one we already made, we could have just copy and pasted those ones right into here and gone in and changed the tools. Would have saved us a bit of time, but, you know, things happen. So next, multi-axis posting, no changes. Right here, we're going to go to our tool crib. We're going to go to the end mill rough and make sure to pick the cross mill and hit OK. Next, again, we have our patterns, advanced pocket, and I'm going to do this again with a morph spiral. I like the morph spiral a bit. For this one, I'm going to go pretty low, though. I'm going to give it a 15% step over. Next, again, we have our parameters. So we're going to leave 15 thousandths on the wall. We'll go ahead and do this and we'll say 2 passes. And then finally, the leads. This one you might need to do something on. It's basically a slot. There's nowhere where we can start cutting this part off of the part. We have to plunge into the material here. We didn't drill any holes. We don't really have anything. So I would go with something like a ramp and then just set up a radius or a length that you'd want to use. I'm using a 1/4 inch tool. I'll go with a 1/4 inch ramp. We'll try that out, see what it gives us. And yeah, see what we get. So sequencing, I'm just going to turn on optimized. Linking, no changes. Feed rates, no changes. MDI, no changes. And finally, we get to the finish tool, where we will go to the end mill rough once again and make sure to pick the cross mill tool. And for the patterns here, we're going to do our compensation left and G41. our parameters, I'm just going to clean up the 15 thousandths this time. For our leads, this one, I'll go with a circular lead, but you know, I tell you guys the rule of thumb that I follow, and it's just because it's easy, is when you're doing your leads, do them based on the tool. Just give it half the tool diameter, so the radius of the tool. So in this case, I could use an 1/8 inch. I tried this out earlier. The slot's a little too small for an 1/8 inch, but I can go with something like a 1/16 of an inch. The reason I could go smaller than this is because I have space for it. Because of the way I'm compensating my tool on the patterns page here, the system's already compensating me an 1/8 of an inch. This is just a lead in to get me, you know, not perfectly on the wall and enough to keep me away from the wall. So if I need my G41 comp, I have the lead in move to do that. All right. Corner types, no changes. Sequencing, optimized. Advanced feeds, no changes. And finally, the MDI. And when we're all done, we're going to hit finish because I want to hit save. And then I'm just going to right click on that feature 2 axis and say compute all toolpath. And there it is. So we'll blank that out. And here's our pocket. There's our first. There's our second right there. And then we have our profile finish. Actually, no, totally lying. The groove that I couldn't fit the bigger lead in was this one, not the one we're using now. So I could totally go back into my finish pass here, edit this, leads. I mean, honestly, I think a 1/4 inch would honestly fit. Let's find out. 1/4 inch lead fits just fine. So yeah, wrong groove. Other than that, that should be everything. Again, as you guys can see, I mean, it's not super difficult. Now, when you get into the MDI and stuff, that's a whole game changer. I hate doing all that stuff. It's, you know, there's no joy in it at all. This, after you get your tool crib set up, most of the time turns into a pretty simple little, you know, tool pathing part. You can use 3-axis tool paths. I haven't used any. I don't use them too often on mill turn, but there's definitely a time and a place. Let me go ahead and just say save on this once again. And we're going to try and launch the simulation, see if we get any errors. I think I changed all the settings that were giving us errors last time, which is I put it on longhand mode. So yeah, it's loading right now. This is a sign that usually everything's good. Now, if you get an error, and for those of you that have used the mill turn a bit, if you've gotten the error that tells you that your tool is not for a 4-axis machine, I mentioned it at the beginning of this, but the 2 things you want to look at if that's the case is the tools, make sure the tool that you selected was the correct tool. So the correct tool, for me, for the face is my 1/4 inch end mill that's perpendicular to the face. If I accidentally went and selected the cross mill 1/4 inch tool, then I would have a hard time. John asked, what does MDI mean? MDI is manual data input. Essentially, if you want BobCAD, like on this part, I'll just reload the simulation here in a second. If you wanted to do a cutoff transfer, so you want your sub spindle to come in, get out of here. You want your sub spindle to come in and grab the part, and as it's, and then your sub spindle and your main spindle would sync up, and then you'd perform a cutoff, and then the sub spindle would go home. For us to show that in the simulation, you have to enter that information into the MDI. So these are all the commands that you could use. And it's not just that. There's a lot of reasons you would use MDI. And you didn't hear it from me, but it's coming in the future to mill and lathe in your milling and turning in BobCAD. So eventually we'll have it. I don't know when. I'm hoping as soon as possible. I've just heard that they're working on it. Might not even be supposed to tell you guys, but be ready for that. We're going to have some of that. But really, it's just for adding kind of quick commands into your code without going in and editing your code a lot of times. My favorite option for it is raw text. I can put a direct string, a line of text, or a set of codes in between features. I get a lot of guys that use this. They'll say after the operation. So you go after operation. They have a line. they call this M00 or M01, and they have their optional stop on, and then they add a command, and it's just raw text. And what they'll do here is they'll just say M0 or M01. So after that operation's done, they come in, part stops, they can go in, give it a little inspection, and when they want to go again, they just hit run on the next one. Right now, to do that kind of stuff in BobCAD, you have to manually edit the code, which it's not a big deal for a lot of people, but if you're fresh to G-code, you don't know much about it, editing G-code is one of the scariest things, because if you make a mistake, it's going to go on the machine with the mistake in it. So it's, we don't want you to have to go edit your code. That's why we have a whole posting department that'll hopefully modify the post the way you guys need it. But that's basically, it's manual inputs of data. So you can, no, I don't want to delete that. So you can just kind of add things into it. If you've ever stood at your machine and punched in a little code, little movements on the machine, that's your manual data input. It's you just entering it in. A lot of machines have the word MDI on it as well. So, all right, so back to the, I'll just hit compute. Back to the simulation. So let me just say save. I always save before the simulation. I know I just saved like 2 minutes ago, but I'd much rather wait for the 10 seconds it takes for something to save than the couple minutes it takes if I lose the shut down BobCAD and have to go back and redo all my tool pathing. So yeah. All right, so I have my workpiece on right now. You can see it right there. I don't like to have the workpiece on while I'm viewing it the first time. I like to turn that off on when it's done. And let's go ahead and check this guy out. We'll turn it down kind of slow and just see what we get. Now, I did set it up so that the order that I'm cutting my part in should be the order in which it does this whole thing. So unless I made a major mistake on something, we should be fairly good. There we are, opening up that pocket. By the way, right now I'm on workpiece stock. So my part is sitting still. My tools are rotating around it. You could also go with a tool focus and you'll see how the part's going to move, but the tool stays still. Or you could go with machine, which kind of gives you the view of the whole thing. And it's kind of everything. Just depends. So I totally was machining through my chucks when I did, or through my jaws when I did the groove there. That's why I'm getting a collision between the stock and the tool and some other things. But yeah, we're just opening up that pocket. I'm going to go back to this one. Ignore the tools spinning around the tool. We're just looking at how the tool's going to run. So there's that finish pass. Now we're going to start swiping away at the outside here. And just taking it down a few levels. All right, looking pretty good. I'll speed that up a little bit. This is taking too long. Come on. There you go. So just cleaning it up. You can see there's not a lot of meat left around there, but there's enough. I'm probably going a little less aggressive than I could be. It's going to extend my machining time, but I'm not too worried about it. There's our center drill. We cleared that face, which is big. Sometimes you don't. We got our center drills for those, and then our pockets for the outside. And there we go. That's our first depth. I think we got 2 of those. So it's you'll see it zigzag again down at the bottom. Yep, there's our zig, gets to depth. And then I think I went with like a 15 or so degree or 15% step over. So not too crazy on that, but yeah, now it's going to do the other side. We'll speed that one up. This should be the almost the last thing. We just got the profile finish after this. Get those tools out of our view. There we go. And it's just going to clean that up. Right there, and finish pass. So there we have it. Now, for the fact that if I look at my machine right now, and I'm machining through my jaws whenever I do anything that's there, That's all handled. You can make a quick change for it right here by clicking on these little arrows that are next to the cam tree. If you don't have those little arrows, it means you're on a version that doesn't have them, which I can't remember what version they came out with. 30. It might have been new to 33, but they might have been in 32. I can't remember. What you could do if they're turned off right now, you can find it up in the settings, or if you follow the cursor down to the bottom of the screen, right here next to this little magnet button at the bottom, there's enable and disable the flyouts. That's how you could turn them on and off. I love having them because I can go right here to the machine setup, click on those arrows, and then right here for my work offset, I currently got it pulled out 5 inches. And that's now the problem is it's 5 inches off of the face of the chuck, not from here. They don't count the faces of the jaws as 0. So if these are 2 inches or so, I only got about 3 inches of my part sticking out. That would be the 5-inch total. So I'm going to go with another, let's go 6.5 inches. I'll say apply, and then I'll close the simulation. We have to close it and then reopen it for it to take that change. Again, make sure you got your new number. And then for this one, I'm not worried about collisions or anything. Normally what I say is don't fast forward through the simulation. But now that I've done that change, I just want to make sure I'm not machining through those jaws that are showing on there. And to do that, I'm just going to grab this progress bar, slide it all the way to the right. It's going to load and kind of catch up with everything. And then we'll see the result. And there we go. You'll see, I mean, I didn't have the, let me go back to this one. Yeah, there, closer, let's go drill. Those jaws don't, I guess they were in there, right? Center drill. It's just changing the view right now. Seeing if I could close them up. I can't remember how to close the jaws. I think that might be a setting for the thing. But really, all I'm really looking at on that now is I want to get kind of square to the front face of this machine here, and then zoom in on it, and just kind of line it up with the jaws. Find out we got a bit of extra material there. So yeah, I don't think we're going to have any collisions when we do that groove this time. We shouldn't have anything going past that. So there we go. And again, if you go to your visibility and you turn on your workpiece, you can compare what you've cut out to the part you have. And it looks like we got to go a little bit, maybe a little too much in that corner. Might have to clean up a little bit. Or when I pick my geometry, I might have to pick the top edge. That might be it. Yeah, but yeah, there it is. Any questions? Does anyone have anything? Whoops, I want to try this real quick. Remove that. Let's go ahead and reselect. Oh, I took a weird path that time. All right, get out of here. Never mind. I'll pick it myself. I'm just trying to fix this thing real quick, see if it makes that change or if it's going to gouge on the bottom now. So there's that one. Before I picked the floor edges of this, and it gave me a different result. So just running around, just like that. Bottom should be good. Chains, we're going to start in the middle, and they're going to the left. That's good. Go right there. Okay. And then we can go and compute that toolpath again. And I don't know if that fixed it or not. It might just be gouging in a different spot now. If the bottom was too low or whatever happened before. But again, we could save it and run through the simulation real quick. Come on. There we go. Yep, fast forward all the way through. And there we have it. Whoops, bring that over there. And let's see if there's still that gouge at the top. We're cutting, I think we're cutting too, no, it's pretty close. I think we are cutting a little too much of the pocket there. And that's why we're seeing the white. If I turn my workpiece to transparent, yeah, we're cutting into that wall a little bit more, but that's more on the geometry side of things. It's, I mean, this is, I don't know if this is a true 4-axis wrap pocket. It doesn't seem like the walls are fine, but it's getting too much of a tilt on it when it does that back corner there. So I'll have to play around with it, find out what it's doing. If we turn the workpiece off, looks fairly good, but there's definitely something wrong there. Yeah, overall, there it is. So that's it. I'm going to go ahead and stop this.